Mr. Clelland for Clelland Maths. This is a National 5 Application of Maths 2026 Ultimate video. It is going through every single topic, question by question by question. You can get a PDF on clellandmaths.com and you can follow along on the app. Links are in the description. Remember, we've also got our last minute live streams the night before the exam where I go through all my predicted questions. Massive success last year, so don't miss out on that. Let's get going straight away. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClellandMaths at leckyscotland.co.uk. Their practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClellandMaths to get 30% off that. Link down below. SQA National 5 Application of Maths 2024, Paper 1, Question 6. Jamie bought 2 identical birthday cakes. This is a trick question, this. His friends ate 2/3 of the first cake and his family ate 3/4 of the second cake. Calculate the total amount of cake left over. So a lot of you, I think, is going to go just straight ahead and went 2/3 plus 3/4. Add them together. So that's 12 when you times. 2 4s is 8. 3 3s is 9. 9 plus 8 is 17 out of 12. And then thought to yourself, oh no, 17 is bigger than 12. How can there be any left over? I mean, what you don't realise is there's 2 cakes, both cut into 12 pieces. So to start with, there was 24 pieces out of 12. 24 out of 12 is 2 cakes, yeah? So I need to do 24 minus 12, 24 minus 17, sorry, which is 17 plus 7 is 24. So that means that there's 7 12s left over. And we're done there. SQA National 5 Applications of Maths 2023, Paper 1, Question 3. The crowd at a rugby match is made up of home, away, supporters and people who are neutral. 3/5 are home, 2/5 are away. Calculate the remaining people that were neutral. So this is your standard adding fractions then taken away to get up to 1. So I need to first of all do 3/7 plus 2/5. So our common denominator is 35. That's just by times the 7 and 5 together. And obviously you can see that this one on the left has been times by 5. You can think of it as a cross. 3 5s is 15. Plus this one on the right has been times by 7. So 2 7s is 14. 15 plus 14 is 29 out of 35. So neutral is just going to be the difference between 35 and 39 to get back up to 35 out of 35. So 29, 30, 31, 32, 33, 34, 35 is 6 out of 35. And just a quick check if that's simplified. It should be, hopefully, but the only numbers that go into 6 are 2 and 3 and 6. 2 doesn't go into this number, 3 doesn't go into this number, and neither does 6. So we're done there. SQA National 5 Applications of Maths 2025, Paper 1, Question 1. At a school, pupils voted to elect the head prefect. 3/8 voted for Fraser. Gracie got a 1/5. Alison received the rest. Calculate the fraction that Alison received. So we're just adding these fractions. So 8 times 5 is 40. 3 5s is 15, plus 8 1s is 8. 15 plus 8 is 23. So 23 out of 40 is my total, but I need to take away from 1 to see what's left over. The easy way to do that is 40 minus 23, which is 17, which means that Alison got 17 out of 40. And as long as that's simplified, we're done there. SQA National 5 Application Maths 2025, Paper 1, Question 5. Julie scored 78% on a science test. Science, 78%. And 32 out of 50 in math, or maths. Where did she do better? Well, I need to compare these. So I've already got a percent, so I'll change the other one, the fraction, into a percent. So I need it to be out of 100. So if I can make it out of 10 first by dividing by 4, that would work. 4/8 is 32. And then just make it out of 100. So that's 80%. So better just in maths because 80% is bigger than 78%. And we're done there. SQA National 5 Apps 2021 Paper 1 Question 7, converting fractions to decimals. Convert 3 sevens to a decimal fraction, give you an answer to 3 decimal places. 3 divided by 7 is what we need to do if you're going to convert a fraction to a decimal. So setting that up, I've got 3 to be divided by 7. I know I'm going to need some decimals, so I put a point and just put a bunch of zeros. I've put 4. Why 4? Because I'm rounding to 3, so I need an extra 1. 7 does not go into 3, so I carry my 3. 7 4s are 28. 29, 30, carry 2. 7 2s are 14. An extra 6 makes 20, so carry 6. 7 8s are 56, so carry 4. 7 5s are 35. And then it's going to keep going, but I'm going to do 4 because I'm going to go down to 3. So then our final answer to 3 decimal places is 0.429 because 5 says round it up to 9. And again, take your time on this, write out your 7 times table if you're going to get stuck. SQA National 5 Applications of Maths 2019, Paper 1, Question 6. Write the following values in orders from biggest to smallest, greatest to least. Justify your answer. By justifying your answer means make them all the same so you can tell instead of just guessing, okay? So we've got decimals, fractions and percentages. I think the easiest way to do this is to change them all to decimals. So if you try to change them all to fractions, you need to make them the same denominator. So let's have a look at our decimals. We've got 0.388 first, then we've got 3/8. So that means we've got 3 divided by 8. 8 does not go into 3. So to deal with that, I add some zeros on here. Doesn't matter how many, just a bunch, so I can keep carrying if I have to. 3 left over. 8, 16, 24, that makes 3. 6 left over. 8 5s is 40, 6 is 48, 7s is 56. 4 left over. 8 5s is 40, and then I'm done because there's no left over, so 3/8 is 0.375. Now we've got a percent, 38.38%. To change that to a decimal, we just divide by 100. 38.38 divided by 100. To divide by 100, just imagine where the point is, and it's just going to jump back. All the numbers move. So 0.3838. So now putting them in order from biggest to smallest. The biggest one I've got is 0.39 still. And then we've got 388 or 383. 388 is next. And then I've got 383 and 375. Well, that's 383 then. And then 0.375. So changing them all back to the way it was, that was 0.39, 0.388, 38.38%, and the last one was 3/8. And we're done there. SQA National 5 Applications of Maths 2023, Paper 1, Question 6. Kenny buys a new fridge, the original price was $6.50. The shop is having a sale with 20% off all fridges. It then says he goes into the shop and he gets an additional 2.5% off the sale price. How much does he pay for a fridge? Do not be tempted to take away 22.5%, 20 and 2.5. That is not what's happening here. You're getting 20% off, then you've got a new price. Then you're taking 2.5% back off. We always try and trick you with this one, especially when you don't buy carpets, so be careful with that. Let's do 20% then. So 20% of 650. Well, the easiest way to do that is find 10% by dividing by 10, so that's 650, and then double it up to 20% to get £130. So we now know we're getting £130 off. So the new price, before we get the additional bit, is 650 minus that £130. That gives me 5 minus 3 is 2, and 6 minus 1 is 5. £520 is the sale price. Now I need to take away 2.5% of that. So 2.5% of £520. Now, 2.5% seems quite unwieldy with a non-calculator paper. So a couple of ways you could do this. Do 25% and divide by 10, or how I always like to think of it, find 10%, half to find 5%, half again to find 2.5%. So if I find 10% of 520, that's divided by 10, so I'm at 52. That means 5% is going to equal half of 52, which, being very careful, is 26. 2.5%, which is half again then, is 13. So that means my next new price is 520 minus £13. You might just be able to do that without any sum here and get the answer of 507, but just in case you are doing a sum, borrow from here to get 1, and that's 10. 10 minus 3 is 7. 1 minus 1 is 0. 5 minus nothing is 5. So he pays £507. And we're done there.
SQA National 5 Applications of Maths 2018, Paper 1, Question 8. Ian buys a new sofa. The original price was £700. The shop is having a sale with 25% off. When he goes to the shop, he gets an additional 5% off the sale price. Calculate the price he pays. Don't make the mistake of trying to take 30% off. That would be wrong. It's 25% off first, get the answer, then take off a further 5%. So let's work out 25% of 700. Now you might know that 25% is a quarter, but if you don't, here's the main ones for percentages. Know how to do 10%, divide by 10. Know how to do 1%, divide by 100. And a handy one is 50%, divide by 2. Anything else you can just make up from a combination of 10s, 1s and 50s. So let's work out, I'm going to work out 50% first, just by halving. Half of 700 is 350, because then I can just go down to 25% by halving again. So half of 3, 2 into 3 goes once, with 1 left over. 2 7s is 14, with 1 left over. 2 5s is 10. So £175 off is how much it gets. So the sale price, don't make a mistake of thinking it's 175, that'd be a great deal, but it isn't. It's 700 minus 175. So borrow from there to make 6, and that gives me 10, which I'm going to borrow straight away to make 9. And I'm going to make 10 here. So 10 minus 5 is 5, 9 minus 7 is 2, 6 minus 1 is 5. The sale price is 525. I now get an additional 5% off. So I need to work out 5% of 525 now. So again, remember I told you 10%, 1%. You can go 1% times 5 or 10% and half it. I'm going to go 10% and half it. So 10% divided by 10 is just 52.5. So 5% is half of that. So if I can't do it, I'll work it out like this. 2 2s is 4 with 1 left over. 2 6s is 12. 2 2s is 4 with 1 left over. Nowhere to go, add a 0. 2 5s is 10. So it's £26.25. So how much does he pay? Well, my previous amount was 525. So I do 525 finally, minus £26.25. So add a couple of zeros. I'm going to borrow from here to make 4, and that's 10. Borrow from 10 to make 9, and that's 10. 10 minus 5 is 5. 9 minus 2 is 7. Can't do 4 take away 6, so I'll borrow from here to make 14. 14 minus 6 is 8. Can't do 1 take away 2, so I'll borrow again. 11 take away 2 is 9. And finally 4 take away nothing is 4. He pays £498.75. And we're done there.
SQA National 5 Applications of Maths 2023, Paper 2, Question 8. Jacqueline buys items online and sells them in her shop. She bought a painting for £320 and sold it for £415. Calculate the percentage profit she made. We need to work out how much she made then out of how much she bought it for. So we do 415 minus 320. I am getting tired on this one, so let me just get a calculator. That gives me 95. So our percentage profit is 95 out of 320, which is what she started with. She made 29.6875. Oh, I need to times that by 100, sorry. Times by 100 to get as a percent, 29.69%.
And question 10C. After starting the training program, Andy could run 5.6 miles in an hour. After question 10 continued, before starting the training program, Andy could run 5.6 miles in an hour. After completing the program, he could run 7.2 miles in an hour. Calculate the percentage increase in the distance that Andy can run in an hour. Okay, so percentage difference is like a fractional increase. So I will need my difference between the end and the start over the start. 7.2 minus 5.6 is 1.6 out of 5.6. So 1.6 out of 5.6 is that number, but then I need to times that by 100 to get a percent back. So that equals 28.571%, or about 28.6%. And we're done there. Clelland Maths, today we've done National 5 Applications of Maths 2025, Paper 2, the full solutions. Quite tricky to get that done on camera, especially with all the diagrams that you need to do and the measuring and stuff, but hopefully you found that useful. See you soon. SQA National 5 Applications of Maths 2019, Paper 1, Question 5. Alana takes out a loan of £4,500. The interest plus the administration fee is 7.5% of the loan. The total loan will be paid back in 9 equal monthly payments. Calculate the monthly payment. So I need to add on 7.5% and then divide by 9. So let's start with 7.5% of 4,500. Now this is non-calculator, so I always find it easier just to find 10% and then half and half again to get 2.5% and take away. So in other words, 10% divided by 10 is 450. That means that 5% divided by 2 is 225, which means 2.5% divided by 2 again is, well, 1, half of 5 is 2.5 or 50. So that means that 7.5% is equal to either your 5 and plus your 2.5 or your 10 minus your 2.5. I think adding's easier. So 225 plus £112.50 equals 50. 5 and 2 is 7, 2 and 1's 3, 2 and 1's 3. That is how much 7.5% is. So the total repayment, that's equal to the loan amount, 4,500, plus the 3,750. Put a 0 on there. 7,384. 48,3750 is the total. So far, we have got a mark for getting 3,3750 and a mark for realising that we had to add that on, and then we'll get a mark for now dividing by 9, and then we'll get a mark for actually getting the answer correct. So don't worry if you can't do it all, you still get marks for your working, okay? So last bit, I do 4837.50 divided by 9. So 9 times table. 9 4s is 9 1s is 9, 18, 27, 36, 45. That's 5 with 3 left over. Start again. 9, 18, 27 is 3. 28, 29, 30, 31, 32, 33, 6 left over. 9, 18, 27, 36, 45, 54, 63 makes 7. 64, 65, 66, 67 leaves 4. 9, 18, 27, 36, 45 is 5, and then a 0. So the answer is 537.50 per month. And we're done there. SQA National 5 Applications of Maths 2019, Paper 2, Question 6. Denise bought 375 shares for £4.50 a share. She later sold them for £5.20 a share, and she had to pay 2.7% of the total selling price for commission. Calculate her profit. So we need to work out how much she bought them for. So looking at the bought price, we did 375 times 450 a share. So that's a calculator job. That gives me 1687.5, 1687.50. So that's what she bought them for. And then in terms of sold them, we've got £5 375 times £5.20. 375 times £5.20 is 1950. Normally that would be your profit, the difference between these two numbers, but she has to pay 2.75% of the selling price. So I need to work out 2.75% and take it off. So 2.7% of 1950. That gives me 52.65. So that means that her profit is simply 1950 minus 52.65, because that means that's how much she actually made, and then take away how much she sold them, bought them for originally, 1687.50. 1950 minus £52.65 minus 1687.50. That is a profit of £209.85. And we're done there. SQA National 5 Applications of Maths 2018, Paper 1, Question 10. David sat a class test. His results are shown below. Paper 1, 35 marks, and he only got 8%, and Paper 2 was out of 65 marks, and he got 60%. Calculate the number of marks achieved in Paper 1. Well, we got 80% of 35. So again, same thing I said before about percentages, work out 10% first, or 1%, or 50%, and do a combination. So I'm going to do 10% because 8 tens is 80. So 10% is equal to 3.5 marks. So 80% is equal to 3.5 times 8. 8 fives is 40. 8 threes is 24, plus 4 is 28. He got 28 marks. Part B, calculate his overall percentage for the test. Well, we know the marks in Paper 1. We might as well work out the marks in Paper 2 and do the marks out of the total marks to get his full percentage. So his marks in Paper 2, he got 60% of 65. So 10% equals 6.5. So 60% is 6.5 times 6. 6 fives is 30. 6 sixes is 36. 37, 38, 39. So we got 39 marks. So in total, you got 39 plus 28. 67, and it's out of 65, 70, it's out of 100. So you got 67 out of 100, but out of 100 is a percent, so we got 67%, and we're done there. SQA National 5 Applications of Maths 2018, Paper 1, Question 6. Tom thinks the answer to the following calculation is 8.7. Is Tom correct? You can't just say yes or no. You need to actually work it out. And this is BIDMAS question. You've got timesies and pluses. So this is our order of operations question, which BIDMAS does help. Now, a little note on BIDMAS. A lot of people make this mistake with this question. Divide and multiply are worth the same. So if it's a divide and multiply only, you just do it in the order it's written. Same with add and subtract. They're worth the same. So once you get it to just add and subtract, you do it in the order it's written. Not the order that's here. Don't do add then subtract. Just do the order of the sum that is written. So what do I mean by that? I'm going to do my times sum first. So let's do my times, because multiply comes before add and subtract. So at the side, I need to do 4.6 times 3. 3 times 6 is 18, carry 1, put a point in. 3 fours is 12, plus 1 is 13. So my sum turns into 27.2 minus 13.8 plus 4.7. And if you were just remembering BIDMAS and thinking you need to add before subtract, you might try and add these first and then take away from there. And that would actually be wrong. There's lots of reasons why it's wrong, but the main thing for you to remember is when you've just got takeaways and adds, do it in the order it is written now. So I do 27.2 minus 13.8. So being careful with my sums, I need to borrow to get 6 and 12. 12 minus 8 is 4. 0.6 minus 3 is 3. 2 minus 1 is 1. So I've got 13.4 for my takeaway. So I add that on to 4.7. Showing all my work in, and it's helping me to do my sums. 7 plus 4 is 11, carry 1. 4, 7, 8, and I get 1. So the answer should be 18.1. So is Tom correct? Not correct. Tom not correct, all right. And there we go, we are done there. SQA National 5 Application of Maths 2024 Paper 2 Question 1. A school currently has 1,200 pupils. The number of pupils is expected to increase by 5.3% for the next 4 years. Calculate the expected number after 4 years to 3 significant figures. So for this question, this is appreciation. So I'll do 100 plus 5.3 to get that percent, which is 105.3%. I divide that by 100 to get it to a decimal. Use a calculator anything you want, but I know that's 1.053. So now it's just 1,200 times 1.053, and the power is 4. So we press equals and we get our calculator out. 1,200 times 1.053 to the power of 4, 1475.348, blah, blah, blah. Get rid of the calculator. 3 significant figures means I'm cutting here, so that becomes 1, 4, 5 rounds up to 8, and then I get a 0. 1480, let's say, pupils. And we're done there. 2022 National 5 Applications of Maths Paper 2, Question 1 said, a soft drinks company currently has sales of 240,000 bottles in a year. It is predicted that sales will decrease by 4.2% the next year, then increase by 5.3%. Find the predicted value after 3 years. So this is an appreciation and depreciation question, all in the one question. So the first thing is decreasing by 4.2%. So I need to do 100% minus 4.2%. And that gives me 95.8%, which as a decimal is 0.958. You just divide it by 100. Doing the same for the increase, I need to do 100% plus 5.3%, 105.3%, or 1.053. At the moment, you have got 2 marks, one for getting each of those decimals. Now to get your sum. So we've got 240,000 times 0.958 times 1.053. And now I need to check, is there any years or powers I need to add on? So it's decreased by 4.2% next year, so that's just 1. 5.3% in each of the following 2 years. So 1.053 squared. If I can get the squared and the sum, then I get a mark there. And then our final mark is just for getting the answer and rounding it. So we put it all in a calculator and you get 254937.36 and a bunch of other numbers. But we round that to 3 significant figures. So that's 1, 2, 3. We're cutting here. So that becomes 2, 5. The 4 rounds up to 5. And then I put zeros for the rest up to the point. So I've got 1, 2, 3 more numbers. And I better put my pound sign in to be on the safe side as well. £255,000 for our final mark. SQA National 5 Application of Maths 2025 Paper 2 Question 2. Aisha earns an annual salary of £46,900. Following a pay deal, her annual salary is increased by 1.7% for each of the following 3 years. What's her annual salary after 3 years? So I need to do 100 plus 1.7 to get 101.7%. Divide that by 100 then to get 1 point, using a calculator to be on the safe side, 1.017, and that's my multiplier because this is just appreciation. So it's 46900 times 1.017 to the power of 3 to give us 49332.79. The three significant figures then, with a pound sign, cutting here, so I'm rounding down, 49300, and we're done there.
Question 4 continued. The hotel bought a different mirror for the ballroom. The options for the mirrors are shown in the table, so you can buy some different things here, fixing, backing, glass colour, thickness, standard anti-glare, blah blah blah. Right, let's just look at what it wants. The hotel bought a mirror with an area of 3 square meters. Okay. The hotel chose the following options for the mirror, so we need to just be very careful to pick the correct options. Option 1, 4mm thick silver glass. 4mm. So let's go to our table first so we get the right thing. Glass colour and thickness is the bottom. It's 4mm. So that's bronze, that's silver. So the one we're picking is this one, 4mm silver. The next one says anti-glare glass coating. So looking for glass coating is the top, standard anti-glare. So I can highlight this is the one we've picked, anti-glare. Next bullet point, standard fixings. So looking for the fixing column, which is the second one. It's a row, sorry. Basic, standard, premium. Standard is the one we want. So I can mark that one. And the last bit is a foil backing. So backing is the third one down. No backing, foil backing. There's my foil backing here. Now, of course, it's going to ask us how much this costs. Calculate total cost of the mirror. Okay, so just need to add everything up. Taking a note of the fact that we also have an area of the mirror of 3 square meters, which we'll probably need. Let's do each bullet point in turn, or do it in order from top to bottom. It's up to you. I'm just going to do it by bullet point. So 4mm thick. So we look at the price. It says price per square meter, £38. So I need to do 38 times 3 because it's 3 square meters. That gives me 114. I'll put my pound signs in at the end. Now we've got our next bullet point, which is the anti-glare. So let's look at the price of that one. Our anti-glare is £16 per square metre. So we've got 16 times 3, because it's 3 square metres. That gives me 48. Our next bullet point, standard fixings. Standard fix. So they're £32 per mirror, so that's just £32. And the last one, foil backing. Well, in the table, our backing is costing £20 per mirror, so that's just £20. All the answers just get added up. That's the cost of my mirror. So total cost 114 plus 48 plus 32 plus 20 equals, not even going to bother trying to add that myself. Let's get a calculator. Take full use of your calculator. £214. So put the pound sign in. 214. And we're done there. Okay, question 7 continued. Dougie wants to have soft play for the DJ with a DJ for the party. The table below shows the price per child per hour. And the party starts at 4 and it ends at 6. Calculate the total cost of 13 children for soft play and DJ. So, reading information from a table, number of children is the first column. I'm here because it's 13 children between 11 and 15. I want soft play and a DJ, so not soft play only. Not party bag, not food. Soft play and DJ is this one, so it's that price, £5.20 per hour. So I need to do £5.20. That's for 1 hour. It's between 4 and 6, so 2 hours. And it's for 13 children times 13. That gives me 135.2, so £135 and 20 pence, and we're done there.
Question 10. A youth group's planning a fundraising night to help pay for a trip. The expenses for the night are shown. They sell 200 tickets. They need to make a profit of 2,000. Calculate the minimum ticket price to achieve this profit. So here's all the expenses. So the total expenses, just add them up. 340, 50, 770 and 40. That's 9, 16, 20. That's 10, 12. That's £1,200. If we want to sell 200 tickets and make a profit of 2,000, so that means that we need to do 2,000 plus 1,200. The total amount we need to make is 3,200. So I need to do 3,200 divided by 200 tickets. Knocking the zeros off. 2 goes into 3 once. 2 goes into 12 6 times. Minimum price is £16. The advertised purchase for a deluxe bathroom is £6,700. It can be bought with a payment plan. The payment plan is £325 more expensive than the advertised price, and it consists of 12.5% of the advertised price plus 50 equal instalments. So first bullet point, I need to do 12.5%, 12.5 out of 100 times 6,700. That gives me £837.5. £837.50, so that is the deposit. Now it says I've got 50 equal monthly instalments, but the payment plan is 325 more, so it costs 6,700 plus 325, that's £7,025. So I've paid a deposit, so I take away the deposit and then I divide by 50. So I do 725 minus 837.50. That's 6187.50. So then I just need to divide that by 50 because it's 50 equal instalments. Divide 50 and you get 123.75. So 123.75 per month, and that's my final answer. Buy a new dining table from a shop. It is advertised at a price of £800. She wishes to use a payment plan to buy the dining table. The total price is 14% more than the advertised price. This account is sold. That's the quarter of the total price, 10 equal instalments, a final payment. Calculate each monthly instalment. Okay, total price we need to know so far first. 14% more, so 1.14. 100 plus 14 is 114%, times 800. £912. Now, let's do each bullet point in turn. So the first bullet point, quarter of the total price, so 1/4 of 912. So 912 divided by 4, in other words, is 228. That's the deposit. And she's got a final payment of £100 and then 10 equal monthly instalments. So her total price is 912. I'm going to take away the deposit of 228, but I'm also going to take away the £100 at the final payment, and that will tell me how much I've got left to pay over 10 months. That's £584. So monthly payment is equal to 584 divided by 10. £58.40. SQA National 5 Applications of Maths 2025, Paper 1, Question 2. Laura's buying a picture. She looks on 3 websites to find the best deal. We've got website A, £21.50 for £3.49 postage. Website B, £35, 30% off, free postage. And website C, £30, a quarter off, and then remember the postage of £2.80. Determine the website which offers the best deal to buy the picture and get it posted. Use your working to justify your answer. So let's look at each of these in turn. Website A, well, that's just £21.50 plus £3.49. So I can just do a little column sum, or whatever you feel. 9, 5 and 4 is also 9. 3 and 1 is 4. And then we've got 2, 2499. I'll just put a wee pound sign, make sure the dot. Website B is £35, but you get 30% off. So 30% of 35. Well, I can do 10%, which is 3.5 or £3.50. And then 3 10% will be 30%. So that's £3.50, 7, 8, 9, £10.50. And that's off. So it's 35 minus £10.50. Now, how do you work that out? Well, I can just take away 10 to get 25, take away 50 pence to get £24.50. And just double check there's no postage charge there. No, it's free, so I can continue. The next one, C, £30, you get a quarter off. So a quarter of 30. Well, I can half it to get 15, and then half it again to get 7.50. We're just using a little bit of mental maths, or you can do a bus stop sum. Take that away. So if I take away £7.50, at least we've got £2.50. So that's £22.50. And then check if there's any postage. Don't forget that. Postage is £2.80. So I need to add £2.80. 0, that's 3. 245, and that's 2. So £25.30 for C. So we want to work out the cheapest one of them. So A is £24.99, B beats it at £24.50, C is £25.30. So shop B is the cheap. It's probably a website it's called, wasn't it? Website, just to be clear. B is cheapest. And we're done there. Buying. What's the lowest price for buying 36 boxes of tiles? So we need to do best buy for shop ABC. So let's start with A. It's £26 per box, and it's a special offer, buy 2, get a third half price. So if he buys 2 and gets a third half price, we need to work out how many deals he needs. So that's 3 boxes in a deal. So 36 divided by 3, that goes 1 and 2, so 12 deals. And now we work out the cost of one deal. So one deal is £26 a box. He buys 2 of them, and he gets the third one half price. Half of 26 is 13. So 2 times 26 plus 13. Use a calculator for any sums you want to use a calculator for. So one deal is £65, which means 12 deals, because he's been doing this 12 times now, is 65 times 12, which is £780. Quite expensive. Okay, let's check B. So for shop B, it's £32 a box, and you get 30% discount when you buy 20 or more boxes. Well, he's buying 20 or more boxes, he's buying 36. So I need to do, let's just split this up, 32 times 36. That's 1152, but he gets a 30% off, so you could do times 0.7, or I think most of you have just done 30 divided by 100 times 1152 and then took it away. 34560, that's his discount. So it's 1152 minus 345.60. So he pays 806.40. So there's that deal, there's that deal, and then we've got a C. And for deal C, it's just £22 a box, standard price. So that's an easy one, 22 times 36 boxes. That's 792. So we've got 780, 806.40 or 792. Well, the best deal is shop A. So he's going to use shop A as the cheapest at £780. And we're done there.
6. Continue. Lorna visited Switzerland and decided to buy some cheese. The cost of 5 types of cheese is shown in the table, and it's 250 grams, Swiss francs. Okay, so she got 3 different deals for buying the cheese. Best buy question here. Lorna's going to buy 250 grams of each cheese. Use working. Determine the best deal for buying all 5 cheeses. Use working to justify your answer. So, 5 out of here, 5 out of here, or 5 out of here. And she's going to buy 250 grams of each cheese. Right. It's already 250 grams. So we just need to now just use these prices with each deal. So just do it bit by bit. Let's do deal A. You buy all 5 for 1850 francs. Okay, so that's just 1850. There's no sum. Don't overly complicate things. It's not saying 1850 each or anything, just 1850. So we've given us that one. So part B says buy all 5 and get the cheapest free. Okay, so all 5. You get the cheapest free, which is this one. So we just don't add them together. So we just need to add these 4 numbers. So £2, 2.50 plus 7.50 plus 7 plus 3, because the other one's 3 anyway. So 750, 8, 950, 20. It's going to be 20 in total, 20 francs. Use your calculator if you have to at any point. Part C, buy all 5 and save 15%. Okay, so I need to buy all 5. £2.50. It's not pounds, it's francs. 7.50. 7, 3, and 2. Well, I've already worked out the previous was 20, so that's 22 francs. You save 15%, so you get 15% off. So there's 2 ways to do that. Since we're on a calculator paper, take away 15% to get 85% and times by 0.85, or work out 15% and take it away. I'll do it the first way because it's quicker. So if you're going to save 15%, that means you're going to pay for 85%. So 0.85 times 22. No way I'm doing that without a calculator. 18.70. Determine the best deal. So we started off with 1850. B was 20 and C is 1870. Let's just highlight the ones there. Therefore, deal A is the cheapest and therefore the best buy. Deal A is best as it's the cheapest. You could then say, to be over egging this, 18.50 is less than 20 and 18.70. Let's just leave it.
National 5 Application Maths 2022, Paper 2, Question 6b says a customer wants to buy 12 powder fire extinguishers and 12 stands. The recommended price of 1 powder is £78 and the price of a stand is £15. But the following deals are available. Company A, Company B, Company C. To encourage the company to buy from him instead, Pepe offers a 5% discount on the cheapest of these deals. How much will Pepe charge the company? Well, we're going to have to work out how much each deal is to find the cheapest one and then take away 5%. So Company A, it says buy 2 fire extinguishers and get 1 free. So I'm buying 12. Every time you buy 2, you get 1 free. So that is 3 fire extinguishers. So I need to do 12 divided by 3, which is 4. So that means I'm going to get 4 deals, which means I'm going to do 4 times 2, which is 8 fire extinguishers. So I need to work out the cost of 8 fire extinguishers. 8 times £78. But then I've got the price of the stands. The recommended price of 1 stand is £15, but all stands are reduced by £2.50, so that now makes £12.50. So I need to add on 12 times £12.50. Do both of these sums in a calculator and add them together and you will get £774. Okay, deal B, so remember we're buying 12 of each. Deal B says a sixth of the recommended price of all fire extinguishers and you get a free stand. So we don't need to work out the price of any of the stands, we just need to do a sixth of the price of the fire extinguishers. So the recommended price is £78. So we can do 1/6 of 78. 78 divided by 6 in other words. is 13. So the price of the extinguisher is 78 minus 13, 65 each. And we're buying 12. 12 times 65 is £780. Now we just need to check C. C says 12 powder fire extinguishers and 12 stands for £900. Oh, well, no something to do there, it costs £900. So, best deal equals A, because it's the cheapest. And then it says, to encourage people to buy from me, gets 5% discount, so I need to do 5% of 774. Again, this is all calculator, we could do it without. £38.70, that's how much you're getting off. So it's 774 minus 38.70 gives you a grand total of 735.50 for your final mark. Now the marks on this are a little bit rubbish. You get 1 mark in total for doing A, so if you do any wrong you lose a mark. You get 1 mark for doing B and then 1 mark for your final. And note on the final one as well, instead of doing 5% of it and then taking it away, you could have done it using the multiplier method and just done 0.95 times 774 and you would have got the answer straight away. We continued the shop tracks methods used to purchase a new bathroom, and the three methods use a debit, credit and cash. And last year's purchase methods were in the ratio 342, 342, and it says respectively 172 bathrooms were purchased with a credit card, debit, credit, cash. So 172 is here, and it says calculate the total number of bathrooms purchased last year. So I can work out one part by doing 172 divided by 4, and hope you realise that. So I get my calculator. 172 divided by 4 is 43. And then I just need to do 43 times the total number of parts. So 4, 5, 6, 7, 8, 9. So times by 9. And that gives me 387. And we're done there. Bar charts and the ratio. SQA National 5 Apps 2021 Paper 1 Question 8. The bar chart below shows the medals won by 4 countries in the 2016 Olympic Games. So we've got gold, silver, bronze shown on the bars by these different shadings, I suppose. And part A says calculate the number of medals won by the UK in the 2016 Games. So the number of gold medals, sorry. So 2016 Games for UK is here. I need the gold. So we're starting at 40. We need to know what it's going up in. So we've got 1, 2, 3, 4, 5 divisions. So it's going up in 2s. So 1, 6, 40, that's 10. 20, 22, 24, 26, in the middle makes 27. So we can just write 27 for our answer to that one. Part B says calculate the ratio of gold to silver to bronze medals for France. So we need to know France's gold, silver, bronze. So let's do our gold first for France. We've got 30, 32 on, so that's 2, 4, 6, 8, 10 for the first number. So I'll just note these as I go. We've got 10, 2, the silver, 2, 4, 6, 8, 10, 12, 14, 16, 18, 18. And the last one, 2, 4, 6, 8, 10, 12, 14. So initially we get 10 to 18 to 14. So then we need to simplify that. So we need to find a number that goes into all 3 of them. I can see they're all even, so I'll just half them. So that gives me 5, 9, and 7. And there, I can't simplify that anymore. So I'm done there. SQA National 5 Application Maths 2025, Paper 1, Question 9. A farm has 3 different types of animal. Sheep, cows and pigs. S, P and C are 9 to 7 to 4. And this is a bit a different one for a change. I don't know if you find this hard or not, but there are 180 more sheep than cows. Well, let's have a look at the sheep and cows. There's 9 parts sheep and 4 parts cow. So the difference between them, because there's 180 more sheep than cows, is 5 parts. So I now know that 5 parts must equal 180. So to get 1 part, I can do 180 divided by 5. 5 threes is 15, 16, 17, 18. 5 sixes is 30. So 1 part is 36. So once I know 1 part, I can find all the parts. So how many parts there are? There are 9 plus 7 plus 4 parts. So that's 9 plus 7 is 16 plus 4 is 20 parts. So it's 20 times 36. Well, that's just the same as 2 times 360. That gives me 0, 12, 6 and 1 is 7. There are 720 animals. And if that's what it's asking me, I'm done. How many animals are on the farm? If it asked me how many of each type of animal, I would have took my 36 and times by each of the numbers. But we're done there. SQA National 5 Application of Maths 2022 Paper 2 Question 7 says, Part A, Jamal keeps fish. To make tap water safe for fish, a condition is added. The volume of condition required is directly proportional to the volume of tap water. 5 mils of condition is used for every 20,000 millilitres of tap water. Calculate the volume condition for 14 litres. So we know that 5 millilitres is used for 20,000 millilitres of water. And that's conditioner. I'll just write conditioner. What's the volume for 14 litres? So let's do 1 litre, divide by 20, so 5 divided by 20, 25 millilitres. And then we can go to 14 litres by times and by 14. To get 3.5 millilitres for our final. Okay, proportion. SQA National 5 Application of Maths 2021 Paper 1 Question 14. A 240 gram steak costs £3.84. Complete the label shelf to show the price per kilogram. So 240 grams is equal to £3.84. And I want to get up to 1 kilogram eventually. So we know 240 grams is equal to £3.84. And we want to know what 1,000 grams is. So you can either go down to 1 gram, you can always do that each time, or you can do a bit of clever maths to get there. It's up to you. What I'm going to do actually is get as close to a kilo as I can. So if I times both this by 4, that gives me 960 grams. So I'll know the price of 960 grams by timesing this by 4. 4 fours is 16, 4 eights is 32, plus 1 is 33, 4 threes is 12, 13, 14, 15. So that'll take me to £15.36. But I'm short by 40 grams. So I need to know the price of 40 grams. Well, if I do 240 divided by 40 grams, that's knocking the zeros off, gives me 6. 40 goes into 246 times. So that means I can know that 40 grams is also equal to £3.84 divided by 6. 6 5s are 36, 6 is 36, carry 2, 6 4s is 24. So I now know 40 grams is equal to £0.64. So that means that 1 kilogram just equals £15.36 plus 0.64, which is 0.060 or £16. And we're done there. The shop sells lemonade. There are 2 options. Option A, 24 pack of 250 mils for £7.50. Option B, 10 pack of 330 mils for £3.89. Determine which shop offers the best value for money. So we're going to have to compare like for like. So we're going to have to get the same amount of liquid and how much that costs for each shop. So let's look at option A first. We've got 24 packs. So how much liquid is that? 24 times 250. That's 6,000 millilitres. And for option B to start with, we've got a 10 pack is 330 millilitres. That's 3330 millilitres. We can work out the cost of 1 millilitre, but that's going to give us a very small number, so I'll probably scale it up to make it look nicer. But we do know that that equals 750. And we do know that that equals £3.89. So to work out 1 millilitre, you would do 750 divided by 6,000. I'll show you what that looks like, because you might have done that in the exam. You get 0.00125, and you would do the same for this one then. 389 divided by 3330 is 0.001. I'll just round it to the same number of places, 1168117. So you might be able to see that one's smaller than the other. I can see that B is smaller than A, but if you can't, maybe just scale it up to 1,000 millilitres. And 1,000 millilitres would be an idea just by times it by 1,000. Because if you do that, it'll be easier to see. 0.00125 times 1,000 is £1.25, and 0.00117 times 1,000 is £1.17. And now it's much easier to see that £1.17 is less than £1.25. So, little statement, determine what option offers best value of money. Option B, best value, as £1.17 is less than £1.25. And we're done there.
SQA National 5 Applications of Maths 2023, Paper 1, Question 12. Laura makes and sells fruit smoothies. She intends to buy kiwi fruit in bulk. She considers the following options. Option 1, 35 kiwi fruit for £5.95. Option 2, 45 kiwi fruit for £8.10. Determine which offer offers the best value for money. Use work to justify your answer. Often you want to go back down to one thing, but with a non-calculator paper, that can be quite tricky sometimes. I'd have to divide by 35 and 45. If I can find a way to get down to maybe 5 or 10, it might be easier. Now, you do these both end in 5, so if I can divide this one by 7 5s is 35, that'll get me down to 5 kiwi fruits. And 9 5s is 45, so if I divide that one by 9, I'll get down to 5 kiwi fruits. So I'm going to examine 5 kiwi fruits. So option 1, 35 kiwi fruits cost £5.95. So I can say 35 kiwi equals £5.95. And then that means dividing by 7, 5 kiwi is equal to, I need to do a sum here, £5.95 divided by 7. So 7 doesn't go into 5, so I'll put a 0 point and carry the 5. 7 8s are 56, 57, 58, 59 gives me 3 left over. 7 5s are 35. So 5 kiwi fruit is equal to £0.85, or if you prefer, 85 pence. So now we look at option 2. Option 2 says that 45 kiwi fruit equal £8.10. I want to get back down to 5 kiwi still, so dividing by 9, because 9 5s is 45, gives me 5 kiwi. So that means that I need to do £8.10 divided by 9. 9 doesn't go into 8. Carry 8. 9 9s are 81. 9 nothings are nothing. So £0.90 or 90 pence. So which option is the best value for money? Well, the cheapest one for 5 kiwi. Therefore, option 1 is better value, since I'll write £0.85 is less than £0.90, or 85 pence is less than 90 pence. And we're done there.
Rab employed green plant gardeners to landscape the garden. The company told Rab 3 workers take 10 days to landscape. The company were able to provide 2 extra workers. All the workers work at the same rate, and they work Monday to Friday each week. We start work in the morning of the Monday the 2nd. Determine the date we will finish. Okay. Well, landscape the garden takes 10 days. It's meant to take 10 days. but that's the only bit we're doing, which is to say that 3 workers, 10 days, but we're going to provide extra workers, so it's going to take less time. So this is all about proportion and inverse proportion because it's work getting done. 3 workers take 10 days. So if I want to work out how much 1 worker takes, I do not divide by 3. 1 worker doesn't take less time, it takes more. So it's 3 times 10, which is 30 days. And now I can divide for how many workers I've got, which is 5. So 5 workers take 30 divided by 5, which is 6 days. So now it's just a date problem. We started work on the 2nd of October, which is a Monday. And that's Monday. So the 3rd, 4th, 5th, 2nd, 3rd, 4th, 5th, and 6th. By the end of the week, the 6th of October is a Friday. We take Saturday, Sunday off. So that's Monday, Tuesday, Wednesday, Thursday, Friday. That's 5 days. We take Saturday, Sunday off. So that's 7 and 8. We go back to work on 9th of October. 9th. That's just 1 day. It's 6 days, isn't it? 9th of October. So that's Monday. So there we go. Let's just double check. 2nd, 3rd, 4th, 5th, 6th. Skip. 7, 8, 9. That's 6 days it takes. I'm happy with that. 9th of October. I don't think it gives us a year, does it? Maybe go back to the future. I'll probably put Monday as well, just to be on the safe side. 9th of October. And we're done there.
Garden. It normally takes a team of 4 workers 12 hours to complete the task. The company sent an additional worker to help complete the task. All the workers work at the same rate. We started at 8, took a 30-minute break for lunch. What time did they finish installing the hot tub? Okay, so this is reverse proportion, inverse proportion. Okay, so you think if you're doing work, the more people that do the work, the less time it takes. So 4 workers usually take 12 hours. So to do 1 worker, well, if this was me baking a cake, I would divide by 4 and it would take 3 hours. That makes no sense. 1 worker's not going to take 3 hours, not unless he's at Captain America or something, or a Flash. So it's the opposite, inverse proportion. 12 times 4. 12 times 4 hours, which equals 12, 24, 48 hours. So I now know 1 worker takes 48 hours, and it says how many workers have we got? An additional worker. So we're going to 5 workers now. So now we can divide. We know it's 48 hours for 1 worker. Divide by 5 to get a smaller number. 48 divided by 5. I'm going to get a feeling this is a decimal. 9.6 hours. The usual with this, you get a decimal time, so you're going to have to change that decimal time into hours and minutes. So to change 9.6 hours into hours and minutes, well, we've got 9 hours, and then to get our minutes, we've got 0.6 hours, 60 minutes in an hour, so times by 60. I can do that without a calculator, but let's just do it with anyway. 0.6 times 60 is 36. So it's 36 minutes. Now to answer the question, they started at 8 and took a 30-minute break for lunch. What time do we finish? So we're starting at 0800, and then we're add the 30 minutes anytime you want, just wait to the end. Let's just add our 9 hours. 8 plus 9 is 17. So I'm going to write 1700. Not going to bother trying to change that into PM or AM. It is 5 o'clock, of course. Add my 36 minutes, and I get 1736. Then I need to add 30 minutes. Easiest way to do that is add up to the next hour first. So 36 becomes 46. 56 is 24 minutes, which leaves me an extra 6 minutes left over to get to 1806. So we finish at 1806. Just check we don't ask you for it in AM or PM. It doesn't ask, so it's fine. And they gave us it in 24-hour time anyway.
At Christmas, the shop puts up decorations. Last Christmas, it took 6 workers 5 hours to decorate the shop. This Christmas, there are 8 workers available to complete the same task. All workers decorate at the same rate. How long will it take to decorate the store? Hours and minutes. So we know 6 workers is 8 hours, 5 hours. Now, to get 1 worker, you don't divide by 6 because this is reversed. This is inverse proportion. When you're doing work, you scale up by timesing to see how long it takes 1 person. So 1 worker is 5 times 6, which is 30 hours. So that means that 8 workers is 30 divided by 8 to get back to 1 worker. So usually you would times by 8, but again, inverse, we're doing the opposite, so we divide by 8. 30 divided by 8 is 3.75 hours. So that is 3 hours, and then you just take your 0.75, and since it's 60 minutes in an hour, times by 60 to get 45 minutes. Or you might have known that that was 3/4 of an hour, but there we are, we're done there. SQA National 5 Application of Maths 2024, Paper 1, Question 2. Hamish is doing scientific research involving foals, which will be the horses, not what we need to know. For his research, Hamish must use foals that weigh 49.5 plus or minus 2. Below the weights of 20 foals, calculate the percentage that he cannot use. So we need our max and our min. So let's do our max first. 49.5 plus 2 is 51.5 kilograms, and the min 49.5 minus 2 is 47.5 kilograms. And then we just mark off the ones that are not okay because you cannot use them. So anything between 47 and 51.5 is fine. So that's okay. 46.9, 47.9 is okay. 51.6, nope. 49.7, 49.4, 51.5, 47, nope. 48, yes. 50, yes. 51.8, nope. 48.8, yes. 48, yes. 47.5, yes. 50, yes. 51.4, yes. 47.4, nope. 51, yep. 49.1, yep. 47.6, yep. So let's count my nose. So counting the ones that are not okay, we've got 1, 2, 3, 4, 5. Make sure you don't miscount. 5 out of 20 out of 100 times by 5 times by 5 is 25%, and we're done there. Applications of Maths 2022, Paper 2, Question 6D. Pepe inspects the fire extinguishers of a local business. The fire extinguishers are considered safe if they weighed 10.4 kilos plus or minus 10%. The weights of the fire extinguishers inspected are shown. What is the maximum and minimum weights and determine the fraction that was safe? It's okay. So our max and our min. If we're adding 10%, we can times by 1.1, or we can just do 10% and then add it on. It's up to you. 1.1 times 10.4, or like I said, do 10% of 10.4, then add it on. That gives you a maximum of 11.44 kilograms. And then taking away 10% from 100% is 90%, so that's 0.9 times 10.4, which will give me a minimum of 9.36 kilograms. Or alternatively, like I said, do 10%, which is 1.04, and then just take that away from 10.4 to get 9.0636 and add it on to get 11.44. Now we need to work out how many are safe. So it has to go between 9.36 and 11.44. So you can just tick the ones that are okay. That one's okay. 11.67 is not okay. 9.12 is lower. 10.94 is in between. 11.10 is in between. 9.27 is too small. And 10.55 is in between. So I've got 1, 2, 3, 4 that are safe out of 1, 2, 3, 4, 5, 6, 7 in total. So it's 4/7 that are considered safe for our final mark. 1 for max, 1 for min, 1 for final. SQA National 5 Applications of Maths 2025, Paper 2, Question 9. McKay Marketplace is a grocery shop. All the tills in the shop have a weighing scale. An object weighing 800 grams is placed on the scale. Regulations state that the scale should display a reading of 800 plus or minus 0.05%. The scale displayed 800.6. Does it meet the regulations? So for this question, we have to work out our max and our min because this is tolerance. Max and min. So I need to work out at the side 0.05% of 800. So that is 0.05 divided by 100, because I'm percent, then times 800. So it's quite a small number. That's just 0.4. So our max is 800 plus 0.4, 800.4 grams. Our min is 800 minus 0.4, which is a little bit trickier, so I'll just use a calculator, 799.6. So you can only be between the two numbers. Since 800.6 is bigger than 800.4, it does not meet the regulations. And we're done there. SQA National 5 Applications of Maths 2024, Paper 2, Question 3. A lottery consists of a draw of 49 balls numbered 1 to 49. In a draw, 6 numbered balls are drawn and not replaced. In other words, you don't put them back. Those numbers were 3, 7, 12, 13, 28 and 42. If a bonus ball is then drawn, calculate the probability of the bonus ball being a number of less than 8. So we'll just need to work out how many balls are left. So how many balls are left? I've got 49 balls to start with, and I've took out 1, 2, 3, 4, 5, 6. So there's 43 balls left. So that's going to be a bottom number for my probability. I need to work out how many numbers are less than 8 on top. Now you might be tempted to go 1, 2, 3, 4, 5, 6, 7. But that would be a mistake because some of these balls have already been drawn. So I need to work out what balls I've got. So I've got 1, I've got ball 2, I've not got 3, but I've got 4, I've got 5, I've got 6, but I've not got 7 because 3 and 7 have been drawn. I mean, it's less than 8, so I don't go up to 8. So how many balls is that? 1, 2, 3, 4, 5. 5 out of 43. Check that that's simplified. 5 doesn't go into 43, so I'm done. I can leave that as a fraction or change it to a decimal if you feel you must.
SQA National 5 Application of Maths 2023, Paper 1, Question 5. Eddie runs a stall at a school fundraiser. The game requires 2 spinners to be spun and allowed to come to rest. The spinners are shown, so we've got 1 spinner which is colours and 1 is numbers. A prize is won if 1 spinner lands on blue or green and the other spinner lands on an even number. Calculate the probability of not winning a prize. Well, there's lots of ways to do this, but one of the standard ways is to work out all the probabilities with a sample space diagram is what it's called, or you may just know it as a table. So on one side I'm going to write red, green, yellow, one red again, and then we've got blue. That's our options for the first spinner. And the second spinner goes 1, 2, 3, 4, 5. Might be handy just to call that R, G, Y, R, B. So in the middle is all the chances of things happening, right? So we've got red and 1 could happen, R1, R2, red and 3, red and 4, red and 5. Or we could go green and 1, green and 2, green and 3, green and 4, green and 5. Or we could go yellow and 1, yellow 2, yellow 3, yellow 4 and yellow 5. Or we could get back in red and 1, red and 2, red and 3, red and 4, red and 5. Or we could get blue and 1, blue and 2, blue and 3, blue and 4, blue and 5. So there's all the things that can happen from getting 2 spinners. Now it says a prize is won if the spinner lands on blue or green and the other spinner lands on an even number. So let's start highlighting the winning cells. We can have blue, which is the bottom ones, and it has to be even. So 2 is a winner and 4 is a winner. It also wins if it lands on green with an even number. 2 is a winner, 4 is a winner. So we've got 1, 2, 3, 4 winners. Is that right? Blue and green. And even, well, there's only 4 winners. So how many losers is there? Well, we can either count them or use a bit of maths. We've got 5 by 5 options is 25. Take away these 4 means I've got to lose a chance of 21 out of 25 possibilities. Just double check that is simplified. That's simplified, so we're done. With this question, there is a number of ways you could do this. Basically, you just need to calculate how many probabilities are there, what's the chances of all the things, and you need to work out how many things you don't want to happen. Now, you could have worked out how many things you did want to happen, then add up to 1 and listed them anyway, but that's one of the neatest ways to do it.
Oh look, 2 spinners, SQA National 5 Applications of Maths 2025, Paper 1, Question 8. Leslie ran a game stall at the local gala. The game requires 2 spinners to be spun and allowed to come to rest. The spinners are favoured shown below. To win a prize, B must be landing on a larger number than A. Calculate the probability of winning a prize. So again, we've got 2 things happening at once. So we need to work out all the things that can happen. So imagine that this is spinner A, and that goes from numbers 4, 5, 6, 7, and 8. And spinner B goes 1 up to 8. Now, usually, with these types of questions, you're either adding or you're timesing them together. But in this case, it just says B has to land on a number bigger than A. So I could list it as pairs of numbers if I want, or you can just straight away go and list it as what one wins, what one loses. So let's just do it that way. So this is going to be 1 with all these numbers. Well, that's a loss because 1's always bigger than all of them, smaller than. 2 with all the numbers is always a loss as well. 3 with all the numbers is always a loss. 4 with all the numbers is always a loss because it's still less. 5 or equal to 5 with all the numbers. Well, 5's bigger than 4, so we've got a win, but 5's not bigger than 5. So we've now got losses for the rest. 6 is bigger than 4, 6 is bigger than 5, then we lose again. Then we win for 7 bigger than 4, 7 bigger than 5, 7 bigger than 6, but then we lose. And then finally, we're winning. 8's bigger than 5, bigger than 6, bigger than 7, but we still lose on the end because 8's not bigger than 8. So we now count how many wins there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 wins out of how many there are in total. Now you can count them, or you can do the little trick. 1, 2, 3, 4, 5 along. 1, 2, 3, 4, 5, 6, 7, 8 down. 5 times 8 is 40. There must be 40 numbers. Simplify all fractions in maths. So that's 1/4, and we're done there. Catriona runs a different game at the gala. Players who win receive £5 prizes. When playing the game, the probability of a player winning is 0.15. The game was played 80 times. Catriona gave out 70 prizes, £70 anyway. Is this more or less than expected? Expected probability, you call this. So I just take my 0.15 and I times it by how many times I played the game. That's 80. So I've got that sum to do. Well, I'm timesing by 80, so I can move the decimal up to 1.5, and then that becomes times 8. 8 5s is 40. 8 1s is 8, plus 4 is 12. So I get 12.0, which is, well, 12. So we've got 12 times, I've done it the number of times, times the probability. 12 wins. So 12 wins means that she should give out 12 times 5, which is £60 as the expected. Is it more or less than expected then? More than expected is what she gave out because she gave out 70, which is bigger than 60. And we're done there.
SQA National 5 Applications of Maths 2023, Paper 1, Question 8. Janet travelled by car from her home to a meeting. She arrived at a meeting at 10:15. She travelled 160 miles at an average speed of 40 miles per hour. During the journey, she stopped 50 minutes for breakfast. Determine which time Janet left home. So, we know she arrived at 10:15, so that's like way over here. That's her arrival at 10:15, say. AM. And she travelled for 136 miles at an average speed of 40 miles per hour, so we need to work out the time for that. So let's just make a note of that. We need to work out that time. But then during the dinner, she stopped 15 minutes for breakfast. So I can take away that 15 minutes to start with. So going back 50 minutes. So the easiest way to do that is take away your 15 minutes. That gets me to 10 o'clock. And then the difference 25, 35, 45, that leaves 35 minutes off of 10 o'clock, so that's 9:30, 9:25. Let's just say she stopped there. It doesn't really matter when she did a break. So then the time, well, speed. The time, well, distance equals speed times time. A couple of ways you can do this. If you can remember all your formulas, or a triangle sometimes help, the distance, speed, time triangle, where we want to work out time, so we cover it up and it says distance divided by speed, or we can just rearrange the formula. Time is distance divided by speed. Whatever way you do it, you get distance divided by speed. The distance is 136, and we're dividing by 40. You will probably have to do a sum for this then. 136 divided by 40, 40, 81. 20 is 3 decimal point time then. Add some zeros, it doesn't really matter how many. I'm on 120, so I need 16 left over. Now start counting again. 40, 80, 120, 160. That goes in exactly 4 times, so I'm now on 3.4 hours, which is kind of useless to us. 0.4 of an hour, I'm going to have to change that to minutes. So 3.4 hours. So I've got 0.4 hours is equal to 0.4 times 60, because it's 60 minutes in an hour. That is 24 minutes. How did I do that so fast? Well, if I think about times them by 10, first that takes me to 4, and then it's just 6 left. 4 6 is 24. So 3.4 hours is equal to 3 hours, 24 minutes. So going back up to my little diagram, I need to take away 24 minutes. So let's take away the 24 minutes. That leaves me with 9:01 a.m. And then I need to take away the 3 hours. 9876, 01 a.m. So just to answer the question, left home at 6:01 a.m. and we're done there.
This question says the final event of the heptathlon is an 800-metre run. In this event, another of the competitors scored 1,000 points. By referring to the table, calculate this competitor's average speed over the 800-metre run. Give your answer in metres per second. So let's have a look at the table. 800-metre run, 1,000 points. So the 800-metre run is over here. We got 1,000 points, which is here. So where they cross, it took them 2 minutes and 8 seconds. So there's a key number. It tells us a time, 2 minutes, 8 seconds. So I can write the time equals 2 minutes and 8 seconds. I know the distance because it's an 800-metre run. And I have to work out the speed. Well, there's lots of ways you can memorise all your speed, distance, time equations, or know one of them and rearrange it. Or one simple way is distance, speed and time. And we want to work out the speed, so if we just cover up the speed, it tells us to do distance divided by time. So speed is distance divided by time. Now we need to make sure we get this right. Our time is quoted as metres per second, so I need all this in seconds. So the first thing I need to do is change my time from 2 minutes 8 seconds all to seconds. So my time, working on that, well, 2 minutes is 2 times 60 seconds, which is 120. So our total time is equal to 128 seconds. So now I can do my sum. 800 metres divided by 128 seconds. Using a calculator, you get 6.25 metres . Number 9 continued. Emma intends to fly to Alicante and she considers 2 options: a bus from Edinburgh Airport and then a flight, or drive to Manchester for a flight then to Alicante. The cost for each option are below. So this is one of these questions where I have to convert a bunch of units. So let's watch out how much cheaper. So let's do Edinburgh first anyway, because that's easier. So Edinburgh, return flights are 256, and then it's £14.50 for the bus. So that's all you have to do. That is £270.50, I think. 256, 266, 270. So that's Edinburgh. Now we need to do Manchester. So let's read this. The return journey is 492 miles. Right. Emma's car covers 48 miles per gallon of fuel. Right. So I need to work out how many gallons I'm supposed to start with. So for her fuel, we have got 492 divided by 48 miles per gallon. That's 10.25 gallons. So now I'm going to work out how much that costs. So it says a litre costs this, and 1 gallon is 4.54 litres. So to work out the cost, I've got 10.25 gallons. I need to times that by 4.545, because that's in litres. That'll tell me how many litres. Maybe I need to times how many litres by £1.42. So you can do it in one go, or change it to litres, then times by the price. 10.25 times 4.545 times £1.42 is 66.15. Now let's just check if that's a return journey or a single. The return journey from Emma's house, so that's fine. So that is all. I don't need to double it. So that's the cost of our fuel. Then we've got to add on 152 for the flight and 49 for the parking. So in total, £66.15 plus 152 plus 49 is 267.15. So that's how much it costs to drive all the way to Manchester and then get the flight. So we have to work out which option is cheaper. Well, Manchester is cheaper because 267.50 is less than 270.50. It doesn't ask you how much cheaper, so I'm not going to bother working it out, but it's like £3.35. Would you really drive to Manchester, which is, by the way, a 4-hour drive and back? That's 8 hours to say £3. Don't think so. But there you go. Manchester is cheaper, and we're done there. SQA National 5 Application Maths 2025, Paper 2, Question 10. Andy runs 3.4 miles in a time of 33 minutes. Calculate Andy's average speed in kilometres per hour. And it says a mile is 1.609 kilometres. So speed is distance divided by time. But we want it in hours. So to change our minutes into hours, 33 min equals 33 out of 60 hours. So you can just do that in a calculator. 0.55 hours. And then we want to change our miles into kilometres. So lots of work to do before we even start. 3.4 miles, well, it says 1 mile is 1.609. So 3.4 miles is 3.4 times 1.609 kilometres. Which is 5.4706 kilometres. So then our distance is 5.4706 divided by our time, which is 0.55. .9.9465 kilometres per hour. I'll just round that to about 9.9 kilometres per hour. And we're done there. Emma did choose to fly from Edinburgh. Her plane took off at 11:30. That's in local time. Edinburgh, we'll just put. And Alicante is 1 hour ahead. So the plane flew 1552.5 miles for speed 575 miles per hour. Calculate local time. So I need to work out her time. So what you can remember is this tiny triangle. It's a bit of a cheat, but there you go. And if you cover up the t, it tells you to do distance divided by speed. T is distance divided by speed. The distance is 1552.5 and the speed is 575. So I just divide those put together. Now that gives me 2.7 hours, but I'll need minutes. So for the minute part, 0.7 times 60, because it's 60 minutes in an hour. So that's 42 minutes. So now we know that she is flying for 2 hours, 42 minutes. So add 2 hours, 11, 12, 1, 30. Now, that was 11:30 local time, so I might as well put that in 24-hour time, so 13:30. And then 42 minutes. So add half an hour to get me to 1400, so that's 1412. And then we need to add an hour, because it says Alicante is 1 hour ahead. I want to know the local time the plane landed in Alicante, the Alicante time. So I need to add 1 hour, because Alicante is 1 hour ahead. So that gives me 13. So that gives me 15:12 or 3:12 p.m. if you prefer.
Hi, Jackie wants an item sent from her Dubai shop to her New York shop. It was sent from her Dubai shop at 8:45 local time on the 24th of November. The expected delivery time is 90 hours. Wow. New York is 5 hours behind Edinburgh. Dubai is 4 hours ahead of Edinburgh. Determine the local time and the date item is expected to arrive at our shop in New York. A big one, this one, for the end here. So, 90 hours. We need to work out how many days and hours that is. So I need to do 90 divided by 24. So that's 3.75 days. So that's 3 days. Then the 0.75 part was 24 hours in a day. So that's 18 hours. Now, she's in Dubai at 8:45 a.m. and it tells us different times for Edinburgh compared to New York and Dubai. So let's just work out this and then we'll add in the different times. Okay, so we're at 8:45. So I need to add on 18 hours. So 8 plus 18, if you just use a calculator for that, is 26. But once I hit midnight, it's a new day, okay? So it goes 8, 18, 19, 20, 21, 22, 23, 24, or 0, then 1, 2. So I'm on 2 o'clock in the morning, 45 the next day. So that was starting on the 24th of November. So I'm now on the 25th after 18 hours. I'm now going to add 3 days. 25, 26, 27, 28. So I'm now on the 28th at the same time. But this is Dubai time. Now I need to work out this strange thing of New York and Dubai. So I'm trying to get to New York. And New York is 5 hours behind Edinburgh. Dubai is 4 hours ahead of Edinburgh. So changing to Edinburgh time. I'm on 02:45 on the 28th. And Dubai is 4 hours ahead of Edinburgh. I need to take away 4 hours. Minus 4 hours. Well, that's not going to knock me back a day. That's fine. Doesn't matter. So 02:45 minus 4 hours. So that becomes 01:45, 00:45, 23, 22:45. And that will now be the 27th. So now going to New York time. It says New York is 5 hours behind Edinburgh, so I need to take away 5 hours. So that gives me 22, 21, 20, 19, 18, 17, 17:45, and I'm still on the 27th. of November. And we're done there.
So 5 Application of Maths 2025, Paper 2, Question 7. James travelled from Southampton to New York by ship. It took 80 hours, so he's in Southampton. And he's going to New York, and that journey is 180 hours. The local time in New York is 5 hours behind Southampton. The ship arrives in New York at 0400. 0400, that's New York time, on the 18th of November. Calculate the date and time the ship left Southampton. Date and local time the ship left Southampton. So I need the time in Southampton. So I need to take away 180 hours. And then I need to account for the time difference. So let's just check. 180 hours is 24 hours a day, 7.5. So if I do 180 divided by 24 hours in a day, I get 7.5 days. That's equal 7 days and 12 hours. But remember, New York is 5 hours behind, minus 5 hours. So that means that Southampton is plus 5 hours. So since I want to go back to Southampton time, I'm going to need to add 5 hours. So on the 18th of November, minus 7 days equals the 11th of November at 0400 so far. And then I need to take away 12 hours. So if I take away 12 hours, since clocks go in 12-hour times, 4 o'clock in the morning becomes 4 o'clock in the afternoon the previous day. So I need to take away the day as well and say I'm now on, well, 24-hour time, 4 o'clock is 1600 or 4 p.m. if you prefer. But now I need to take into account the time difference because that's a New York time still. So I need to go plus 5 hours for Southampton time. So 16 becomes 17, 18, 19, 20, 21. 10th of November, 2100 or 9 p.m. if you prefer. And we're done there. A boat sails SQA National 5 Application of Maths 2024, Paper 2, Question 6. A boat sails east from a harbour. The lighthouse is 500 metres due north of the harbour. When the boat is at a position A, 600 metres away from the lighthouse, and then it sails a further 400 metres to B. Okay, we have to calculate the direct distance from position B, and that's the dotted line up to the lighthouse. It looks a little bit hard, this question, but it is a Pythagoras question, because if I could do that squared and that squared, I would have this one. But the problem is I'm missing a little bit, so I could do that bit first. So I'm going to call this one A. And because this is the longest side of this triangle, then A is the square root of 600 squared minus 500 squared. Take away when you find a shorter side. So I can do that all in one go in the calculator. Square root bracket 600 squared minus 500 squared is 331.662, a bunch of other numbers, and we'll call that meters. Now I'm not going to round that now because I'm going to use that. So now I've got a big triangle, and the height is 500 meters. So adding 400, we get 731.662. So now we can just do C equals the square root of 500 squared plus 731.662 squared. Don't worry too much about your rounding. If you did round it, I'm sure you'll be fine. Square root 500 squared plus 731.662 squared. That's 886.188. Now that is quite unwieldy. And the units there are length, so that's meters. So I will round that, I think, to 886.2 meters, or even you could go 886. If you look at all these numbers, only rounded to one significant figure, 600, 500. So even 890 would be fine, but I think 886.2, I'm not going to be bothered about rounding at this point.
SQA National 5 Application to Maths 2023, Paper 2, Question 3. Fiona's having her back garden redesigned. A new fence is to put up from A to B and from B to C. Rows of fence are 3 metres long, cost £22 per row. Calculate the cost of the fencing. So A to B is here and here, so we already have that length, that's 21 metres. So let's just write that down. A to B equals 21 metres. And it wants us to go from B to C, which is from here to here. You'll notice you've got two right-angled triangles, so I can do Pythagoras twice essentially. If I do Pythagoras here, that'll give me this length, and then Pythagoras with these two to get this length. So for clarity, let's call that 1 and 2. So Pythagoras on 1, let's call this little length here just x for the sake of it. 5 squared plus 7 squared is equal to x squared. 5 squared plus 7 squared is a calculator job. 74. So x squared is equal to 74. Now you could just leave that as x squared because you're going to actually square it again when you do the 21 squared before you square root. But I'm assuming a lot of you are going to square root here. So I'm going to find x as the square root of 74, which is equal to 8.6023. But you could have just left it as 74 for the x squared, because now what we're going to do is Pythagoras on shape 2. So for shape 2, just being very careful. This is a hypotenuse across opposite right angles, also hypotenuse. So if I call this side, say, let's call it y, then this squared and this squared I have to take away because I've already got the longest side. So that means that y squared equals 21 squared minus the answer we just got squared. So that equals, getting a calculator, 21 squared minus this answer squared, which is 74, because it's the square root of 74 we had, or just put it in again, is equal to 367. So y is the square root of 367. 19.157 or 19.16. I'll just put that as 19.16. And that's meters. So now we've got both our lengths. We've got 21 from A to B and 19.16 from B to C. So total length (21 plus 19.16) is 40.16. Now it also tells us some information in the question. It tells us that rows of fencing are 3 metres long and cost £22 per row. So I now need to work out, well, how many rows I need to buy. So number of rows is equal to our answer of 40.16 divided by 3 because of 3 metres long. So taking that in our calculator, we get 13.38 with a bunch of other numbers. But that means we need to buy 14 because otherwise we'll be short. So we're buying 14 rows. And then the last bit, they cost £22 per row. So the cost is equal to 14 times 22. And we get £308. And we're done there.
A flag is in the shape of an isosceles triangle with a rectangle on top. Calculate the area. Well, you should know the area of a triangle is half the base times the height. So if I cut this here, I need to know the height of my triangle. So we're going to have to use Pythagoras because we know two sides. So if we call this x, x squared is 13 squared minus 5 squared. That's 169 minus 25, which is 144. So x must be the square root of 144, which is 12 centimetres. So our triangle area, half the base is 10, times a height of 12. That's 5 times 12, which is 60 square centimetres. And then for the rectangle, that's just length times breadth, 10 times 4, which is 40 square centimetres. So the total area is 100 square centimetres. SQA National 5 Application of Maths 2025, Paper 2, Question 6. A badge has been designed in the shape of a right angled triangle with a semicircle. The outside edge of the badge is made of silver. Calculate the length of silver needed for the outside edge of the badge. So the outside edge of the badge is all the way around the outside. So all the way around here. So the problem I've got is I've got two sides, but I've not got this bit. Now that's a semicircle. Circle is circumference. Pi times diameter. So for this one, since it's semicircle, it'll be a half of pi times diameter. So I need the diameter. Well, the diameter is just this line. So that's a right angle triangle. So it's Pythagoras. So let me label that side x. X is just going to be, well, x squared is going to be 6 squared plus 9 squared, because I'm opposite the right angle is the longest side. So x is the square root of all that. So you can just do all that in a calculator in one go. Using a bracket, 6 squared plus 9 squared. $18.816. 10.816. If you prefer, 6, it goes on for a bit. If you prefer, you could have done the 6 squared plus the 9 squared first to get 117 and then done the square root of 117. You'll still get the same answer. So 10.8166 forever. I'll divide that by 2. So 10.8166, and that is the diameter. So I'll just round that to about 10.8. So I don't want to use a massive number there, do we? 10.8 centimetres. So that means that our circumference part is a half times pi times 10.8. Half is 0.5 times pi times 10.8 is 16.9646. 16.96 or 17.0 centimetres. I'll put 17, I think it's a neater number. So that means that my perimeter is just 6 plus 9 plus 17. Which is 32 centimetres. And we're done there. Now if you didn't use 17, if you did use 16.96, you would just get 31.96, and I'm sure that would be fine as well. If you had used the big long number, 10.8166 times 0.5 times pi, you would get 16.99. So you get 0.99. So in any case, you're getting round about the same answer. Even if you use 3.14 times 10.8 something, 16.956. So about 16.95, which rounds up to 17, even if you add in the 166. So either way, you're getting about 17. So there's your answer. 17 plus 9 plus 6, or thereabouts. SQA National 5 Application of Maths 2024, Paper 1, Question 4. Stephen has built a new ramp. Calculate the gradient of the ramp. So gradient is vertical over horizontal from the start of the exam paper, but the units have to be the same. Now let's just change one of these. There's 10 millimetres is equal to 1 centimetre. So that is 85 centimetres. So the gradient is 85 over 165. Well, they both end in 5, so I can divide by 5 on top and bottom. 5 and 8 goes 1 with 3 left over, and 5 sevens is 35. 5 threes is 15, and 5 threes is 15 again. So I get 17 out of 33. 17 is a prime number and 2 17s is 34. So that is it simplified and we're done there.
SQA National 5 Applications to Maths 2023, Paper 1, Question 9. The design of a skate park ramp is shown. The height is 70 centimetres. To be suitable, the ramp must have a gradient of 0.35 plus or minus 0.01. Determine whether the ramp is suitable. So you work out the gradient. The gradient is vertical over horizontal. Our vertical is 70 centimetres, but our horizontal is 2.1 metres. So we're going to have to make it all the same units. So I'll keep it all in centimetres to have bigger numbers. That's 70 over 210 centimetres. So simplifying that, that gives me 7 out of 21. And simplify that again, because 7 goes out of 21 3 times, that's a third. Changing a third to a decimal, well, you should maybe already know a third is 0.333, but if you don't, you can quickly do a wee sum. 1 divided by 3, 3 doesn't go into 1, so add some zeros. 3 threes are 9, add 1, 3 threes are 9, add 1. You should be able to see that it just goes 0.333 forever. And now it says determine if the ramp is suitable. So we've got this tolerance here. So our max, it can be is 0.35 plus 0.01, which is 0.36, and our min is equal to 0.35 minus 0.01, which is 0.34. So the ramp has to have a gradient between 0.34 and 0.36. So is it suitable? Not suitable, because 0.33 is less than the min of 0.34. And we're done there. Gradient in percentages, SQA National 5 Apps, 2021, Paper 1, Question 13. John has a slope in his back garden. The slope is the height of 8 planks. Each plank is 22.5 centimetres. There's 960 centimetres away from the bottom of the slope. Calculate the gradient. So the gradient, remember, is the vertical over the horizontal. So for part A, gradient equals vertical over horizontal. So I need to know my vertical, well, it's 22.5, and it says there's 8 of them, so I need to times that by 8. So 8 5s is 40, carry 4, 8 2s is 16 plus 8 2s is 16 plus 4 is 20, 8 2s is 16, 17, 18, so I get 180, so we get 180 over 960. Always simplify your answers. So I can do 18 over 96, divided by 10, divide by 3 then, 3 6s is 18, 3 3s are 9, 3 2s are 6, divide by 2, we get 3 over 16 as our gradient. Part B. To improve his fitness, Andy wants to complete house sprints. The hill closest to his house has the following measurements. Horizontal distance between the top and bottom is 250. The bottom of the hill is 48 metres above sea level. So you can imagine that we've got the sea down here, and that's 48. And then the top of the hill is 71 metres. So to get the difference, I'm going to have to do 71 minus 48, which is 23. Because it's 71 also from C up to the top. So 23 plus 48 is 71. It then says, his training program states the hill must have a gradient greater than 0.1. So to work out the gradient, to see if it meets the requirements, we need to do gradient equals vertical over horizontal from the start of the exam paper. And now I've just done the work to work that out because I've got my 23. So that's just 23 over 250, which as a decimal, 23 divided by 250 is 0.092. So no, doesn't meet requirements. As 0.092 is less than 0.1 because it's not 0.1 yet.
And we're done there. SQA National 5 Application of Maths 2024, Paper 2, Question 4. A section of gardens in the shape of 4 identical right-angled triangles. It consists of a flower bed surrounded by a patio as shown. The flower bed has a radius of 4, and the patio is the shaded area, that's the outside bit outside the circle. Calculate the area of the patio. Well, if I calculate the area of the whole thing, I'll just need to take away the circle. So that's exactly what I'm going to do. So there's lots of ways you could do this, but I'm just going to treat this as 4 right-angled triangles. So it says the radius is 4. So let me just take a note of that. There's the centre to the outside. So that's 4 metres there. And centre to outside is 4 metres there. So let me just draw out one of these triangles. We've got 5 and 4 make 9 metres on the bottom. And going up the way, we've got 4 and 3 make 7 metres. So the area of a triangle is a half the base times the height, 9 times 7. And I've got 4 of these triangles. Again, this is calculator, so I get my calculator. Half is 0.5 times 9 times 7, and I'm timesing that by 4 to get 126 metres squared. So that's my area of all the triangles together, so the whole shape. I need to take away the circle because the patio is the shaded bit on the outside. So the circle or the flower bed is an area of a circle, and the radius of that is 4 metres. Area is pi r squared. You can get that at the start of the exam paper. Pi times 4 squared. Calculator for that. 50.265 and a bunch of other numbers. So that means that my path area is the whole area, 126 minus the 50.265 that I just worked out. I'll put metres squared there. 126 minus 50.265 is 75.735 or about 75.74 metres squared. Again, rounding isn't really that important. And we're done there. SQA National 5 Applications of Maths 2023, Paper 2, Question 4. A reception area in a hotel features a large mirror. The mirror is in the shape of a square with 4 identical semicircles on each side. The square has length 1.2 metres. I notice I'm not put that on the diagram, so let's just draw our square at the side. Just put 1.2 metres for the sake of clarity for ourselves. And then the semicircles have a diameter of 0.7. So on this diagram, I will just note that this length here is equal to 0.7 metres. It now says part A, find the area of the mirror. So we need the area of the square, add the area of all the circular parts. So the area of the square is just 1.2 squared, or 1.2 times 1.2, length times breadth. 1.2 squared is 1.44 metres squared. And then for our semicircle, now I'm going to do this in one go here. I've got 4 times semicircles, so 4 lots of. A semicircle is half a circle, so it's a half. And from the start of the exam paper, pi r squared for a circle times pi times r squared. So I need to identify my r. Well, r is equal to 0.7 divided by 2. Use a calculator if you have to, but you get 0.35 metres. So now I can do my sum. 4 times a half times pi times 0.35 squared. 4 because there's 4 of them, a half because they're half circles, 0.35 because it's the radius. 4 times a half, which is 0.5, times pi times 0.35 squared. I get 0.7696969, blah, blah, blah. I'll just leave that in the calculator. So our total area is equal to the 1.44 plus the 0.76969. So getting my calculator back out, I'll just leave that in and then add 1.44. So I'll press equals, add 1.44. I get 2.20969, 2.20969
969. Again, it doesn't ask us to round, so we could get away with not rounding, just put our units in, meters squared, or I'm just going to round it for the sake of clarity. That's about 2.21 meters squared. And we're done.
Part B, calculate the area of the grass. So let's have a look at this question. We've got this shape here, which is the grass. So we can split this up into a triangle like we've already done, and then add in 2 rectangles. Or you could do a whole big rectangle minus a triangle, whatever way you prefer. I'm going to do it by adding because most people I think would do that. So I'm going to split it up, going down 1 triangle there, 1 rectangle here, and then another big rectangle here. So let's draw that out underneath. Our triangle is 4 by 2 already. Our rectangle below that, which looks like this, is 2 by, now that's 6, so that means it all the way along's 10, so that's 4. 2 by 4, we've already got the numbers, 2 by 4. And then our big rectangle at the side, the whole height is 4, and then the whole length of it's 6, so it's 4 by 6. So that means our area is just the triangle, which is a half of 4 times 2, so that's our triangle, plus 2 times 4, because that's 1 rectangle, plus 6 times 4, because that's the other one. Do the sum separately if you want. Half of 4 times 2, well, 4 2s is 8, so that is 4, plus 2 4s is 8, plus 6 4s is 24. But remember, this was a calculator question, so you just use calculator anytime you want, and you get 36 meters squared, and we're done there. SQA National 5 Application of Maths 2025, Paper 1, Question 7. A school's designing a play park. It is in the shape of a rectangle and semicircle. Start of the exam paper tells you how to do circles. Calculate the area, but you have to use pi is 3.14. So we've got 2 shapes here. Let's call that shape 1 and shape 2. So let's do the area of shape 1. Well, that's just 20 times 12 because it's a rectangle, which is, well, I can do 20 times 10, which is 200, 2 times 12, which is 40. Add them together to get 240 meters squared. I'm assuming it's meters? Yep. So then the semicircle part, area 2, well, start of the exam paper tells you that area of a circle is pi r squared. So pi is 3.14 times r, all the way along is r. In fact, I'm lying. Half of all the way along is r, so that's 10, because all the way along is diameter. So it's actually 10 squared, even easier. But then I need to half it, because it's half a circle. So let's do a half. Leave the 3.14 at the end, usually because it's easier. In this case, since you're times it by 100, that beats it, I think. 100 times 3.14, a half of 314. So half the 3, 2 goes into 3 one time with 1 left over. 2 5s is 10 with 1 left over. Then you get a 7 centimetres squared. Don't know why I'm writing centimetres. So we've got 2 there. So our total area is just 240, 157, addy, 7, 9 and 3, 397 meters squared, and we're done there. National 5 Application of Maths 2024, Paper 1, Question 9. A banner's being edged with ribbon, shape of a rectangle and 2 quarter circles. So it's a circle question. Calculate the length of ribbon to edge the banner. So it's perimeter, circumference. So we're using c equals pi d somewhere. So let me just write that down. Okay, so imagine if I do that there and there. There's the middle. And then that would be the centre of our circles there. So the length that we've got there was 20 because it's 20 and 20 either side. So we've got this whole length, and this whole length, plus these little bits. And I've got 2 of them. So circumference of the bits is 2, because I've got 2 of them, times, and it's a quarter circle. A quarter times pi, 3.14, times diameter. Well, since that's the radius, then the diameter is actually 40. So 2 quarters, that's a half, times 3.14 times 40. A half of 40 is 20, so that's 20 times 3.14. Again, times by a number ends in 0. That's 2 times 31.4, which is 8, which is 2, which is 6. 62.8 centimetres for the little semicircular bits, and then I need to add on a 40, a 160, and a 160. So it's just 62.8, a 40, a 40. Nope, not 2 40s, stupid me. A 40 only, and 2 160s. That gives me 8, that gives me 2. I've got 10, 16, 22, 1, 2, 3, 4, 422.8 centimetres. Just make sure I've not missed anything. Everything's in centimetres. It's just the edging around the outside. So I'm done there.
SQA National 5 Application to Maths 2023 Paper 2, Question 2. A glazier is edging the perimeter of a window. The window is in the shape of 2 rectangles and 2 identical quarter circles. Calculate the length of edging required for the perimeter. So perimeter is all the way around the outside, so I'm going to have to go 100 plus 2,300 plus another 100. But then it's this arc length here. So you will recall from the start of the exam paper that the circumference of a circle is pi times the diameter. And we have got 2 quarters of a circle, so we work out a quarter and then just double our answer. So for a quarter circle, we have 1/4 times pi times the diameter. Now be very careful here. This is the radius, so the diameter is double this, which is 1,400. Get a calculator out and work that out, but then double it. 1/4 times pi times 1,400, which is 1099.557. So for both quarters, that's 2 times 1099.557. I'll just leave it in my calculator and times by 2. I get 2199.1148. I'll just put ... rather than rounding. So there we go. We've done our circles. So our perimeter is just going to be equal to the answer we just got, 2199.1148 plus, and then we've got 1,000, 2,300, another 1,000. So I'll just write that as I go, 1,000, 2,300, plus another 1,000, plus, now let's be careful with this, I missed it almost. Notice this goes down, along, up, curves, but then you've got this bit in the middle. So how big is this bit in the middle? Let's just work that out. Well, I've got 700 to here and 700 to here. We know that's 1,400. So this bit in the middle is 2,300 minus 1,400. If you need, you can use your calculator at any time, but that is 900. So that extra bit is 900. So we need to add on 900 as well. 2199.1148. No need to round, I'm going to round it in anyway. Plus 1,000. Can't really see that. Plus 2,300. Plus, I think it's another 1,000. Plus a 900. That gives me a grand total of 7,399.1148. Put my ... dots in because remember I didn't round. But if you did want to round, it doesn't ask you to round. A couple of significant figures would be appropriate. So about, I can put that as 7,400 millimetres, I think would be fine. But any reasonable rounding would be okay.
SQA National 5 Application to Maths 2019, Paper 2, Question 5. A hotel is having a swimming pool built. It is in the shape of a rectangle and 2 quarter circles as shown below. The swimming pool will have a safety rail fitted around the edge. Around the edge is perimeter. There will be 2 125cm wide gaps to allow access to the pool. The safety rail is sold in 3 metre lengths. Each 3 metre length costs $11.49. Calculate the minimum cost of the safety rail of the pool. So I'm going to have to work out the perimeter. but then leave a gap of 2 times 125. So perimeter of semicircles, well, we can do the circumference of a semicircle because we get a circumference of a circle in the exam paper. Circumference of a circle from the exam paper is pi times diameter. I've got two quarter circles, so that's one semicircle. So for my circumference part, it's a half times pi times the diameter. Now I need to calculate the diameter. This tells me from here to here is 10, but that's a radius. So the diameter is 20. So the circumference part is 0.5 times pi times 20, which is 31.4159. So we've done this bit and we've done this bit. So now we need to add on the straight bits. Well, we know that this is 36.5, so is this bit. So I can add two 36.5s, so let's just take a note of that. Plus 36.5 plus 36.5, I'll just call this the perimeter. And then I need to add on these two bits here, but since this is a circle, they're a radius, so that's just 10. So another 10 and 10 here. So that's 10 plus 10. So in total, I have got 31.4159 plus 36.5 plus 36.5 plus 10 plus 10, 124.4159 meters. But it then says there'll be two 125 centimetre gaps. So take away the gaps. Now you can't take away 125s because that is centimetres. So I'll change that to metres, which is 1.25 divided by 100. So I'm doing 124.4159 minus 1.25 minus another one because there's two gaps. 121.92 to 2 decimal places. So now we know the whole length we need, and we move on to the next bit, working out the cost. So it says the safety rail was sold in 3 metre lengths. Each 3 metre length costs £11.49. So I need to work out how many bits of safety rail. So number of safety rail, that's just going to be 121.92 divided by 3 because they're sold in 3 metre lengths. So 121.92 divided by 3 equals 40.64. So you're going to have to buy extra because you can't buy 0.64. So you need to buy 41. Then the last bit, each 3 metre length costs £11.49. So I need to do, for the cost, £11.49 times 41. And that gives me £471 and 9 pence. And we're done there. SQA National 5 Application of Maths 2024 Paper 2 Question 2. A snooker ball is a sphere with diameter 5.2. Calculate the volume. Okay, so I need the radius because you can check the start of the exam paper and volume is 4/3 pi r cubed. So half of 5.2 is 2.6 centimetres. So volume is 4/3 pi times r cubed, which is 2.6 cubed. So again, calculate a job for that. 4 divided by 3 times pi times 2.6 to the power of 3. I get 73.622, bunch of numbers, I always put ... Centimetres cubed I'll put here, but we can round that if you want. 73.6 seems reasonable, so I'll just round that so I don't have to constantly go back and type in all the numbers in the calculator. Part 2. The density of an object is calculated using this formula, mass over volume. The mass of a snooker ball is 142 grams. Calculate the density. I'm just going to call D for density. I'm just putting the numbers in. Mass, that's 142 over volume, 73.6. Now with the given answer in grams per cubic centimetre, well, I've got cubic centimetres from my volume up here, so there's nothing. I've got cubic centimetres from my volume here, so there's nothing tricky there. And the grams there, so I'm just doing the divide. That's why it's on the worth 1 mark. 142 divided by 73.6 is 1.929 grams per centimetres cubed, or about 1.93 grams per centimetres cubed, or 1.9. There's no real rounding required here.
SQA National 5 Applications of Maths 2024 Paper 1 Question 7. Container consists of cuboid, triangular, prism. Calculate the volume of the container. So we've got area of the face times the depth. So we've got two faces, rectangle and triangle. So let's do the rectangle first. Drawing this one out, we've got 15 centimetres. And its length, it's not 50, it's 40. So it's 40 centimetres. And then we've got a triangle. And that is 15 as well. And it's 50 minus 40. Let's have a look at that. 50 all the way along, minus 40 gives me the 10 in here. So now we can just work out the area of both of them and times by the depth, when the depth is 20. We'll give our answer in litres. We'll just work that one out in a minute. So 15 times 40. Well, that's just 150 if I times by 0. Well, times by 10. And then times that by 4. 4 nothings is nothing. 4 fives is 20. 4 ones is 4, 5, 6. 600 centimetres squared. And then this one, half the base times the height. That's 5 times 15. That's 75 centimetres squared. So our total 600 plus 75 is 675 centimetres squared. So now we can do our volume. Volume equals the 675, the area, times the 20 depth. So adding the 0 from times it by 10, 6750 times 2, that's 0. 2 5s is 10, 2 7s is 14 and 1 is 15, 2 6s is 12 and 1 is 13 centimetres cubed. Now that is in centimetres cubed, but we want it in litres, so what we're going to do here, well, 1 millilitre is 1 centimetre cubed. So that equals 13500 millilitres, and 1000 millilitres is equal to 1 litre. So dividing that by 1000, you get 13.5 litres. And we're done there. SQA National 5 Application Maths 2021 Paper 2 Question 7. Doug is organising a birthday party for his son, and there'll be 13 children at the party. He's going to give them juice in cups that are in a cylinder, and these are 11 high by 3.5 radius. Each cup will be filled with juice 2 centimetres from the top. He'll give each child 2 cups, and he'll buy juice in bottles which each have 1.75 litres. Calculate the number of bottles he needs to buy. So we need to work out the volume of this cylinder, but without 2 centimetres from the top. So our height that we're going to use is 11 minus 2, which is 9 centimetres. So the volume of a cylinder is pi r squared times h. So that's pi times 3.5 squared times 9. That gives me 346.36. 346.36 centimetres cubed. So that's for 1 cup. So the volume in total that he needs is 346.36 times 2 cups per child and 13 children. So I just times my answer by 2 and 13, you get 9005.375 centimetres cubed. Now we have got litres for our bottles, so you should know that 1 centimetre cubed is 1 millilitre.
So that means that I've got 9,005 millilitres divided by 1,000, because 1,000 millilitres in a litre. So you get 9.005375 litres. You can do that sum in a calculator if you want. 9005.375 divided by 1,000, 9.005375. So now he buys the bottles in 1.75 litre bottles. So I need to know how many bottles. So number of bottles, 9.005 divided by 1.75. That will not be an exact answer. So I'll take my answer on my calculator and divide by 1.75. You get 5.145 and a bunch of numbers. 5.145 bottles. You can't buy that, so I'm going to have to buy an extra bottle. So 6 bottles. And we're done there. SQA National 5 Application of Maths 2025, Paper 2, Question 5. A sports company sells squash balls. They're in the shape of a diameter of 4 centimetres and they're put in cardboard boxes in the shape of a cuboid. Each box contains 2 squash balls. Calculate the volume of the empty space in the box. So that means I need to calculate the volume of the whole box, take away the volume of the balls, and see what's left. Now, start of the exam paper, volume of a sphere, which is what the ball is 4/3 pi r cubed. So I need r, so straight away, not let myself be tricked. Diameter is 4, so r is 2 centimetres. So that means that I can now do what I need to do, which is my whole volume, the volume of the cuboid, we'll call it, minus the volume of the sphere. Now I know a lot of you will do this in 2 steps, so we've got the volume of the cuboid, well that's just length times breadth times height, so 8.6 times 4.2 times 4.2, and I'll not round till the end. So that is 151.704. And then the volume of my sphere, well, I'll say spheres because there's 2 of them. So that's 2 times 4/3 times pi times our radius cubed, which was 2. I'll put units on at the end. You could put it on as you go if you really want to. Times 4 divided by 3 times my pi button times 2 cubed is 67.0206 centimetres cubed. So the volume of my space is just 151.704 minus 67.0206. .6834 centimetres cubed, or if you want to round, 84.7 centimetres cubed, or 84.68 centimetres cubed, and we're done there. Now obviously I've not rounded until the end, so obviously I try to keep my numbers quite long so that there's no rounding errors as we go, but I wouldn't worry too much about it. It has to drop passengers off to 2 separate locations. If we're 6 kilometres on a 227 bearing, then 45 on a 152. Construct a scale drawing, and it's 1 centimetre is 10 kilometres. So I'm going to warn you now with this question. I can't do this as accurate as you would like, but I've tried my best. I've copied it over to a other place. So let's start off. It says 60 kilometres at 227. Now, because it's 227, I need to, using a protractor like this, take away from 180. So 180 minus 227 is 47. And the reason for that is, let me just zoom in on that, a protractor only goes up to 180. So if I turn that around and try and draw 180 to the left, what will happen is I'll run out of space and then I'll need to flip around and go the other way to get the extra. So to get around that, what you actually do is using a ruler, you extend your north line. And then you've got your middle point here. And once, if I went there, I'd have 180 all the way round, so then I can flip it over and do the extra bit, going from the middle again, down the way, and this time I need to go 47 degrees. So then you would just measure round, and 10, 20, 30, 40, 45, 46, 47 would be roughly about there. And I'm just going to mark it on here so I can see it when I take away the protractor. And I want to go 6 centimetres. So I'm going to have to zoom out a little bit. So there's that. Still need to zoom out so we can see. So there's 1 up to 6. So I just join that up to 6 centimetres. And there we are. So I can take away my ruler. And now we start again. So a new north line from there. So I'm just going to draw a nice big one up and down the way because I might need to go down anyway. And you again would use a ruler for that. Now let me just mark in this angle. This is your bearing, and it was 227. And it was a 6 kilometre journey. And the next stage is 45 kilometres on a bearing 152. So the bearing is 152, so that's okay because that's less than 180. So I can now just get my protractor and go right, take it down, north line's there, spin it around, put it in the middle. Make sure it lines up through the zero as best you can. And go round to 152. So on the outside scale, 152 is about there, so I'll just mark it down there as well so that I'm outside of the picture. And I can go to that. And then this time it was 45 kilometres, I think. So 45 kilometres would be 4.5 centimetres. So I get my ruler, spin it round. Don't worry about what my ruler says here because I'm not using that one to measure. I used a picture of a protractor just to show you guys. So again, this might be wildly inaccurate. It probably will be. Let's just get rid of that ruler. And we're at a new position. And now that we knew that was 45 kilometres, and we knew the bearing all the way around to there was 152 degrees. And it's going to ask us now, with constructed scale drawing, the helicopter returns to the start from the second location. Use your joint to estimate the distance and the bearing. So that means that all you do is you get your ruler, there's your start and there's your end point, and you join it up. Now we're going to need a new north line, so you would draw a north line using a ruler, and you would get your protractor back. Bearing is going to be that little angle in there. So in my protractor, that's about 9 degrees. Now you've probably got a different answer based on your drawing, but I'm going to say my bearing 009 degrees, 3 digits for a bearing. And then I just need to measure the length there. So I'll use that ruler that I've got, 8.567. Again, wildly inaccurate on an iPad, but 8.7 centimetres, but that's times by 10, so that's 87 kilometres, and the bearing is 009 degrees, and we'll be done there. But make sure if you're thinking about this question, don't think about my answer, but more about the method on how to do it, because my answer will not be very, very inaccurate. The mark scheme will usually tell people to check their answers rather than tell you what numbers are in it. So it's more about the method than the actual answer. So hopefully you get the idea that you're doing bearings like that. National 5 Application of Maths 2025, Paper 2, Question 8. The start of an orienteering course is being planned. Competitors leave start point and run on a bearing of 335 for 400 metres to A. They then, from A, run on a bearing of 30 degrees for 320 metres to B. Construct a scale drawing to illustrate this part of the course. Use the scale 1 centimetre as 100 metres. And let's go. So taking a lot of information before we start, it's 335 degrees for 400 metres, but 100 metres is a centimetre. So we've got 335 degrees, 400 metres, which is 4 centimetres. It then said 30 degrees, and the distance for that was 320 metres. So I divide that by 100 to get 3.2 centimetres. I want to draw 335, I have to put my protractor on, but if I do that and go to the right like I meant to, I want to go around 180. So I'm going to have to work out the difference to go to the left. So I'll need to do 335 minus 180. Which is 155 degrees. So when you're going past 180, I'm going to have to extend my north line. So you just get your pencil and draw a nice vertical line going down the way. And now that I've extended it, I can take my protractor and I can take it to the middle and turn it round so that I can get into there to draw all the way around the other side. Line a protractor, making sure it's going through the zero. And we've just worked out we need to go all the way around to 155 degrees. So that is up there. So we'll just make a mark up there on our page, and then we'll join it up with a straight line. Line my ruler up, and I want 4 centimeters. So I'll just draw a nice 4 centimeter line, as accurate as I can, and then we'll get rid of the ruler. So the next one we have to draw is 30 degrees for 3.2. So we need another north line at our new point. So that's point A, remember. New north line, starting again. We need to draw 30 degrees, so we get a protractor, goes in the centre, through the zero, as best you possibly can, and make a mark at 30 degrees, and then join it up. So I've lined my ruler up through my mark, and remember that was 3.2 because it's 320, so 3.2, get rid of the ruler, and that's point B. Now we can label this and stuff. So between here and here, we've got, and that was 400 meters, which is 4 centimeters on my diagram. And then we've got 30 degrees here, and that was 320 meters, which is 3.2 centimeters on my diagram. Now, usually we then ask you to work out the distance going back, but it doesn't tell you to do that in this question. But if you were to do it, you would then just join up the points from here back to there and measure that distance. Then you'll just get your ruler and then times it by 100. And we're done there.
SQA National Application of Maths 2019, Paper 1, Question 8. Sailor's driveway is sloped as shown. Cross-section driveway is in the shape of a right angle triangle. The base is 4 meters long and makes an angle of 12 degrees as shown. Construct a scale drawing of the cross-section of the driveway. So a scale drawing needs a ruler and a protractor. 4 meters, but it says use a scale of 1 centimeter, 0.5 meters. So 0.5, 1, 1.5, 2, 2.5, and so on. Makes an 8 centimeter drawing I need, plus a 12 degree angle. So I'll just take a note of that. I need to draw 8 centimeters and 12 degrees. So let's get a ruler first of all. So here's my ruler. Now your ruler starts at 0 and you go along to 8. Sure you're accurate. Let's get a 0 there. And we draw a nice 8 centimeter line. Get as close as we possibly can to that end. And there we are, 8 centimeters. Let's get rid of that ruler. Now we need a protractor to draw the 12 degree angle. So I've already got a picture of a protractor here I can use. So going to the end of my line, making sure the middle line's up. It's going through the 0. So there's my protractor. Now notice when I'm using my protractor here that it's going through the middle 0. So this is me going up here. And I want 12 degrees. So I've got 10 degrees and then an extra 1, 2. So putting that in 10, 11, 12, there's 12 degrees there. So I make a little mark with my pencil and get rid of my protractor. So line my ruler up through the mark in the end of my line. I'll just draw a nice big straight line, even go past if I have to. And then we're going to join up the end vertically up here. Now I can get vertically with my ruler just by turning it around. But we'll make sure we're joined up, get it nice and neat, and there we get our straight line. And you can obviously then delete any of the extra lines that you don't need. But essentially there is our scale drawing. We can mark on that's 12 degrees, and that would be 8 centimetres, which is equal to 4 metres. And we've got our right angle here. Part B says use a scale drawing to calculate the gradient. So gradient, remember from the start of the exam paper, is vertical over horizontal. So I need to get my ruler again and measure the vertical length. So I need to measure the length of my line. So making sure that that's vertical, I've got it on the 0, 1.5, 1.6, about 1.7 centimetres there. 1.7 centimetres, obviously much easier to do on a bit of paper rather than using electronic tools. But that means that our gradient is 1.7 over 4. Sorry, 1.7 over 8. Which we can't leave it as a 1.7 over 8, so times both by 10 to get 17 over 80. The gradient, so it's 17 over 80. And we're done there.
So earliest temperature on a Wednesday is 37.5 degrees C, and on Thursday it's 98 degrees Fahrenheit. Mark both temperatures on a thermometer and determine which day should have a higher temperature. So 37.5 degrees, so let's have a look. We have got 30, 35, 36, 37, 38, so it's in the middle here. 36, 37, 38.5, so it's right in the middle there. So anywhere in the middle there is fine. And that's degrees C with 98 Fahrenheit. 90, now it doesn't go up in ones, it goes up in twos because there's only 5 divisions, 2, 4, 6, 8. So it's clearly that that is much smaller than that, well not much, but a little bit, isn't it? So what day did she have a higher temperature? On Wednesday. Wednesday. Because 37.5 degrees C is bigger than 98 degrees Fahrenheit. And we're done there.
SQA National 5 Applications of Maths 2023 Paper 1 Question 2. A lorry's speedometer is shown. The lorry's speedometer is restricted to a maximum of 56 miles per hour. Use the speedometer to calculate this speed in kilometres per hour. Okay, so let's have a look at this. Miles per hour is on the outside. Kilometres per hour is on the inside. So I need to find 56. Well, let's see if it's going up. Always check if it's going up in ones or not. So it goes up in ones on here. But on the inside, you should be able to see it goes 0, then 20, and there's only 10 in between. So it's actually going up in twos. There's 10 in the middle. So be very careful there. Now let's try and find 56. So we'll zoom this right in. Miles per hour, 55, 56. So there's my 56 here. Taking that straight across, you could have used a ruler for this, but I can do it quite like that. It's going to be right there. So I just need to count the kilometres per hour. Remember, this is going up in twos. So it's 82, 84, 86, 88, 90. We get 90 kilometres per hour. Usually a mark for marking it on the diagram and then just for reading it off. Okay, question 1 was about Stephen blowing up his tyres, and you're given this diagram. And in order to be safe, the tyres should be blown up to a pressure between 35 and 45 psi. It blew them up to 230 kPa. Is this at a safe pressure? So let's find 230 on this diagram. Well, that's here. So lining that up to here is where it is on PSI, and that's 31, 2, 3. 33 psi. It has to be between 35 and 45. No. He blew them up to 33 psi, which is below the minimum safe pressure of 35 psi. Done.
Question 7c. Rab modernised the house. The work done is shown in the table. So preceding task, time and days, this is going to be one of those charts. So complete the diagram below to show the tasks and time taken for each. So let's start off with no preceding task is A and 7. So you just put A and 7 in the first box and away we go. Right, what comes after A? We've got B, which takes 10, or way down there, F, which takes 18. So does anything come after B? Well, not really until right at the end, so that's going to be the short one. So that's B there, and that takes 10. So we can take a note of that one. And then, watching out, it's F next, and that takes 18. So F is here for 18. And then after F is E, which is 15. And we've got two tasks, but it won't matter which for these. After F is also G for 11. And then after E and G, make sure it does say E and G, we get 9 for C. And then after C, we get D for 8. But also after C, we get H for 6. And then finally, you've got I after B, D, H. Just make sure you've got B, D, and H. Yep, and we're done. So we've completed the diagram. Excellent. So now it says, calculate the minimum time required for the renovations to be completed. It's really asking you the critical path. So what you do is, if I go this way, I'm going to have to wait until all of this is finished, because that only takes 10. You can see tasks here that take lots, so I can't go that way. So I'm going to have to go this way somehow. So I do A and F, so let me just take a note of that. I do A then F, and then after F, it's either E or G. Now, E takes 15 and G takes 11, so I'm going to have to do E, and G's just going to have to hang out. So that's E, and then I get C. And then similar thing, I've got two tasks, D and H. D takes 8, D takes 8, H takes 6. H is going to wait until D's finished, so it's D. And then after D is I. So then we just add up all the numbers. We've got 7, and then I think it was 18. 7, 18, 15. And then you've got C, which is 9. And then D, which is 8. And then 1. So getting a calculator out, 7 plus 18 plus 15 plus 9 plus 8 plus 1 is 58, and the units were days, so it's 58 days is the minimum time. Okay.
SQA National 5 Applications to Maths 2023, Paper 1, Question 10. John owns a bike shop and has a team of mathematics. John owns a bike shop and has a team of mechanics to build each new bike. The table lists the tasks that have been completed, so we've got a precedence table to complete. Complete the diagram below showing we're writing these tasks and the times in the boxes. So we've got the first one of them's already been done for us, D and 2. So there's our D, which is 2 minutes. And before D, we've got G, H, I, and J. So G, H, I, and J could go in these boxes, and we kind of need to work from there. But I'm going to find our first one first, because I always work from the start. Our first task is F, because it's got no preceding task, and F has got a time of 2 minutes. So I can write F and 2 in this first box here, because that's our first task. Now, after F, we have got this one, and that's it, 2 tasks. So the easiest way to do this is trial and error. Try it one way. If it doesn't work, just go back and try again. So let's just try it one way. After F, we could have attached bicycle to bike clamp stand. That's A for 1 minute. And then we could just knock that one off. Looking at A, after A, we could have B and C and H. Well, I've not got enough space now in that place, so I could just delete that A and go, look, I need 3 places to happen. So I need to, if I go here, I'm not going to be able to do it. Here, I'm going to have to go this way. So there you go, A has to go in there. So deleting that, I can put my A and 1 in here. And go back up to where A was. And then we've got B, C, and H. Comes after A. So again, I'll just put them in anywhere. B, C, and H. Taking a note of our numbers, 1, 7, and 5. then I'll just check what comes after B. So B, C, and H is done. After B, we have got J. So we could put J here. And J is 3. And after J, let's hope it's D. Yes, it is, so that one's in the right place. Or it could go that way, it doesn't really matter now. After C, looking down this list, we've got inflate hash for 4 minutes. So we've got I takes 4 minutes. And just check after I, we go back to D, because if not, we need to do something else. After I, we go back to D, so that's okay. And then check H. What comes after H? It's D, so that one's okay as well. So now we can go back down to this branch and complete. After F is E, that is 1 minute. So I can put E in 1. And after E is G for 1 minute. So I can put G in 1 and just double check that after G, we go back to D, which we do here. So we've done that one. So we've completed our table. John thinks that the table mechanics will have a bit greater than 50 minutes. Is he correct? Well, how you do these precedence tables is you start at the start. So I've got task 2 minutes. And then it's the longest of these two, which is 1 minute. So add 1 minute. And then when I move on, I need to wait until the longest of these is finished. So that's 7 minutes. So 7 minutes. And then it's the longest of these two, that's 4 minutes. And then it's 2 minutes at the end. So that's the critical path, we call that. 7 plus 3 is 3, 2 plus 3 is 1, plus 7 is 10, plus 4 is 14, plus 2 is 16 minutes. Is the minimum time. John is wrong since 16 is bigger than 15. And we're done there.
SQA National 5 Applications of Maths 2025. Paper 1, question 3. A company produced the following table to show all the tasks involved in manufacturing and packaging chocolate eggs. So we've got our table, and then it says complete the diagram below to show the tasks and the times. Now there's lots of ways to do this. You can guess as you go. You can make a quick sketch outside of it and see what happens. Or like I say, just guess as you go and then rub it out if it's wrong. That's one way to do it. Or check how many tasks come after each and then try and count it as you go before you put that in. The first task is H, it says, and H is 120. So that's the one with no preceding task. It's not necessarily at the top of the table. We then look to see what comes after H. Well, we've got A. So A probably goes in the top, but if it doesn't, I'll change it in a minute. And that takes 600 seconds. So I write 600. Okay, so I'll just check what comes after A. There it says A because D, that's 105. And similarly, after D then is C, which is 1800. And then after C and I is B, which is 30. So after C and something else, there's B, that's 30. So now I need to check what comes before B. Well, before B is C and I. So in other words, after H must be I. We can check that there. H is I, that's 180. So this one must be 180 for I. And then I'll check my other root for H, we get G, which is 240. And then after G, we get E, which is 60. And then after E, there's only one task left. E and B is F, which is 45. We're just double checking. E goes to F and B goes to F. So we're quite happy there. Calculate the minimum time taken to manufacture and package a chocolate egg. And I wasn't to work out the critical path. So the critical path I can start at H. Now I can either, the route, I'm just looking for the longest route. So I can go 180 and 30, work out that if you want. Clearly 240 and 60 is bigger than that, but clearly 600 and 105 and 1800 is the biggest. So I'm going to go take H, then go A, D, C, and then I'm going to jump down to B and then along to F. So I'm going to need to add up those numbers. 120, 600, 105, 1800, 30 and 45. That's 5 and 10. That's 2, 3, 4, 5, 6, 7, 8, 9, 10 again. That's 6, 7, 8, 16, 17, and then 1 and 1 is 2. 2,700. Is it in seconds? Yeah, seconds. Now I'm pretty sure that'll be the answer that we're looking for because it's only worth 1 mark, but you could change that into minutes. If I wanted to change that into minutes out of curiosity, I would divide by 60. Well, I can take a 0 off and say 270 divided by 6. Well, 6 3s is 18, 6 4s is 24, 25, 26, 27, 6 5s is 30. So it's actually a nice round number of 45 minutes. I divided by 60 because it's 60 seconds in a minute. And we're done there. National 5 Application Maths 2024, Paper 1, Question 8. Tabitha is a van driver for a supermarket that provides home deliveries. Orders are packed into boxes for home delivery to customers. The dimensions of the box and internal dimensions of the van are shown. So everything's in centimetres, which is good. All boxes are aligned in the same direction. Finding the maximum number of boxes fit in the van. So a standard box packing question, but not usual to find it in paper 1. Don't worry, because remember you round down. So you should be able to divide without having to worry too much. But if you did, I'm sorry. Okay, let's try. So I'm just going to call that the length, the breadth and the height to give me some numbers. And then I'm just going to call that one the length, the breadth and the height. So looking at the ones that can't change, I've got length, breadth and height. But the height is fixed because it has to be this way up. So I can't change what happens with that one. So let's put them in. So the height is 220 on the big divided by the small, which is 20. So this is option 1. And then for our length, we can do length against length, 410 over 60. And we can do breadth over breadth, which is 190 and 40. Okay, so you're probably wondering, well, how am I going to do this? So let's just put all our options in first. So option 2, you can switch round. The height has to stay against the height. But the 410 and the 190 can be divided by the other numbers instead. So I can do 40 and I can do 60. So there's all the sums I do. So it's counting in 60, 60, 120, 180, 240, 300, 360. Then I'd be above 420. So that's about 6. I don't need to actually know it's 6.4. Who cares? 6 is all I can fit in. Same with the next one, 40, 80, 120, 160. 200 is too much. I can only fit 4 in. That's about 4. 20s, 20, 40, 60, 80, 100, that's 5. 20, 40, 60, 80, 100, that's 5. Then an extra 20, oh, that's 11. So I've got 6 times 4 times 11. 6 fours is 24 times 11. Well, times it by 10 is 240. Add 124, 240, 250, 264 for option 1. Option 2, 40 into 410. Well, you can only fit 10 of them in. 60 into 190, 60, 120, 180. I can only fit 3 of them in. And 20 into 220, we already know is 11. So that's 10 times 3 times 11. So 10 times 11 is 110. Times that by 3 is 033. And get 330. So what's the maximum number of boxes to fit in? Max equals 330. And we're done there.
SQA National 5 Applications in Maths 2023, Paper 1, Question 7. Biscuits are sold in tins in the shape of a cuboid as shown. The tins need to be packed into boxes with the lid facing upwards. There are two types of boxes available with the dimensions shown, box A and B. Calculate the maximum number of times going to be packed. Use working to justify your answer. This is actually a simplified version of a box packing because usually you can take your container and just move it around in different positions. But in this case, since this box is the same on the length and the breadth, it doesn't matter whether I turn that around, it's going to be the same either way. I need to keep that lid facing up. So really all I need to do is work out how many of these go in this box and how many of these go into that box, and then just pick the best box. And there's only one option for each. So let's look at box A. So our dimensions are 10, 10 and 15, 42, 51 and 50. So we've got 42 centimetres on one side, that's the length, the breadth is 51, and the height is 50. And we need to know that the length and the breadth need to go along the length and the breadth because the box it needs to be facing up the way, so the height needs to match the height. But 10 and 10 is the only options. And then we've got 15 height, so our 15 matches this one. So this is a big box, I suppose, and this is a small box. And then we've got 10 matches this one and 10 matches this one. So once we've worked out which sides go with which sides, we just divide them. So 42 divided by 10, but only whole number answers, you can't go above. So just do 10, 20, 30, 40. That equals about 4. Notice the little tiddles means about, right? And then 51 divided by 10, that's about 5. 5 tens are 50 with one remainder. And then 15 into 50, 15, 30, 45. It's going to be 3 and a bit. So 50 divided by 15 approximately is 3. So in total, remember we just times our answers together. 4 times 5 times 3. 20 times 3 is 60. So I can get 60 in box A. Now I need to do box B. Box B is exactly the same. So for box B, I always like to set it up as a table. My big box against my small box. Our length, breadth and height. So again, length, breadth and height. So this time the length of this one, depends what you call the length, but I use that, so 45. The other side is 72, and this time the height is 32. And again, we need to have against the height our 15 centimetres because it has to face up the way. And then the 10 centimetres need to go against the other ones. So doing our sums, we get 45 this time divided by 10, which is about 10, 20, 30, 44. I'll use little tiddles. Then we've got 72 divided by 10, which is about 7. 7 tens are 70. And then we've got 32 divided by 15. 15, 30, that's about 2. So our total for this box is equal to 4 times 7 times 2. 4 sevens are 28, times 2 is 56. So determine the maximum number of boxes to be packed. Max is equal to 60 in box A.
So continuing with question 5, the boxes are packed into crates for transportation. They have to be this way up, 8.6 by 4.2, 4.2 is our box, and the crate is 100 by 75 by 40. First thing to check is, are the units the same? They are, so I can continue into my method for this. We have to calculate the maximum number of boxes to be packed into the crate for part B. So this is a box packing question. So I always just draw a little table here. I've got option 1. And I'll always put first the thing that cannot change. So the thing that cannot change is, it has to be this way up. So it always has to be 40 up the way. It cannot, that can never flip. So that's what I'm going to put first, the height. We start with a big number, and then we'll just say length and breadth, call them anything you want. So length is 100, breadth is 75, say. Now, since the height is fixed, I'll just put a wee mark there just to remind myself more than anything else. The height is fixed, so that one always has to be 4.2. So we do 40 divided by 4.2. Because that can't change. Can't put that into that box any other way except up that way. So now we've got 100, so we can do 100 divided by 8.6, length against length. And we can do 75 divided by 4.2. And we'll just work out the answers to all of them. Now remember, you always round down because you can't get bits of boxes. So 40 divided by 4.2, 9. 100 divided by 8.6, 11. Ignore the decimals. 75 divided by 4.2, 17. That's option 1. Now let's do option 2. Well, option 2, 40 divided by 4.2 has to happen again because that can't change. And then we're starting with 100, we're starting with 75, and all that happens is you can change the position of the numbers. So 8.6 goes on the bottom, and 4.2 goes up the top. And now you can see that I've done all the options because I can't change them again. If you could change all three, you would get lots more options. So 100 divided by 4.2 is 23. And 75 divided by 8.6 is 8. So there's our options for option 2. And then at the end, to work out the number, you just times them together. So for option 1, 9 times 11 times 17. For option 2, 9 times 23 times 8. Option 1 is 1683. And option 2 is 1656. So the max that you can fit in is equal to 1683. And we're done there. SQA National 5 Application of Maths 2024, Paper 2, Question 9. Emma's planning a holiday to Spain. Her sister lives in the USA, sent her $100. She exchanged it to euros. How many euros did Emma receive? Now watch this. You need to go back to pounds first, always. So I'm starting with $100 and I'm dividing by the dollar exchange rate of 1.30. That'll get me back to pounds, but then straight away I can times away 1.11 to get back to the euros. So that's the sum you need to do. Do it in 2 steps or 1, it's up to you. 100 divided by 1.30 times 1.11 is 85.384. So always 2 decimal places with money, 85.38. I'll just write euro because I can't remember. I don't really want to bother with the sign. 85.38 euro.
SQA National 5 Applications of Maths 2023, Paper 2, Question 6. Lorna was travelling around Europe. She converted £640 into Polish zlotys. I hope that's right. She was in Poland for 4 days. She spent 340 Polish zlotys each day she was in Poland, and then she converted her Polish zlotys into euros. How many euros did she receive? I hate these questions, they're so silly. If you were in Poland, right, and you're going to change it into zlotys, you wouldn't change it back to pounds first. You would just get told how much it's worth. But for these questions, you're not told what a zloty is worth in euros, so you're going to have to go back to pounds and then back to euros. That's how these questions work. So let's do it bit by bit by bit. Lorna converted £640 into Polish zlotys. Let's do that one first. 640 times, and the exchange rate for zlotys is 4.94. So I can just get my calculator out and write down whatever that is. $3,161.6. So 0.60, because we'll just assume that every currency is decimal. Let's just write zlotys. Okay, next one. She was in Poland for 4 days and she spent 340 Polish zlotys each day she was in Poland. So she spent 4 times 340. Which is 1,360 zlotys. It then says she converted the rest into euros. So I now need to work out how much she's got left. So left is 3,161.60 minus 1,360, which equals 1801.60. Make sure you put the decimal places, okay? Money. Zlotys. So that's what she's got left. And now we want to change it back into euros. So if we go back to our table, we're on zlotys. We can't get to euros. We need to go back to pounds. So divide 1 unit pounds times by the euros. The thing I need to do first of all is 1801.60 divided by her 4.94. That gives me 364. Now notice it says 696. So 70. That's in pounds. And then to change it to euros, 364.70 times that exchange rate of 1.15. Which equals 419.405. So 41 euros. Now, if you did this sum, and I did it earlier, as one go, divide then times straight away, you actually get 419.40 because it will not round twice. I've got a feeling you need to round twice because you changed it, then changed it. So, either way. So, first question was on foreign exchange, paper 1, question 1, and we had to work out the average of this person's earnings, but also, that's the mean, but also change it to pounds. So to work out the mean, you add them up and divide by how many there are, which is 4. To change it back to pounds, you divide by the exchange rate, which is 5 real to the pound. So let's go ahead and add these numbers up. So we can just add in an extra box at the bottom, and we can add these numbers up. So we've got 6 plus 4 is 10, carry 1. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again, carry 1. We've got 6, 7, 17, 18, carry 1. We've got 10, 15, 16, carry 1. And we've got 3, 6, 9, 12, 13. So we get 136,800. If we add them up, we need to divide that by 4. So 4 goes into 13 3 times with 1 left over. 4 4s is 16, 4 2s is 8. So we get 34,200. You get a mark for that. But then you need to remember to divide that by 5 because we need to change it back to pounds. So 34,200 divided by 5. 5 6s is 30, carry 4. 5 8s is 40, carry 2. 5 4s is 20, 5 nothings is nothing. So our final answer is £6,840 for our second mark.
Then in question 7, James spent time in New York, then travelled to Toronto, Canada. And it says that the rate of exchange for a pound to US dollars was 1.28, and he spent all this stuff. He changed £1,500 to dollars. He spent $130 per day for 7 days, and he changed the remaining back to Canadian dollars. He then received $1,363.50. Calculate the exchange rate. That's different. So let's try this. We need to work out how many dollars he got to start with. So part B, we've got 1,500. We change it to dollars, so we times by the exchange rate of 1.28. That's 1920 USD. He then spends 130 times 7. That is 910. Spent. So left is 1920 minus 910. Which is 1010. So we now know that 1010 US dollars equals, it gets told, 136,350 Canadian dollars. Canadian. So if I want to know what 1 US dollar is, well, I'm just dividing by 1010. So I just need to divide this by 1010. So 1363.50 divided by 1010 is 1.35 Canadian dollars. I'll just write Canadian. And we're done there. SQA National 5 Application Maths 2024, Paper 2, Question 5. Akira has an annual salary of $35,670. National insurance paid on a person's salary before deductions. We have to calculate Akira's annual national insurance payment. So this is one we need to watch. Up to 12,584 is 0%. So I'm in the middle here. So I'll do 12% of the difference salary in the 12,584. So it's 35,670 minus 12,584. And it's 12% times 0.2 or times 12 and divide by 100. So again, that's a calculator job. 35,670 minus 12,584 is equal to that. Press equals times 0.2 is 2770.32 and a pound sign is required, of course. So there is the national insurance payment for this person's salary. Akira pays 9.5% of her annual salary into her pension. Her annual income tax is this. She's paid in 52 weekly payments. I calculate Akira's net pay. Okay, so we've got a salary for Akira of 35,670. So 9.4% of 35,670 for the pension. So 9.4%, just divide by 100 if you want, times 35,670 is 3352.98. So that's the pension for Akira, and the tax is this number. So her annual salary, not her weekly, annual, because we've already done everything as an annual payment, is 35,670 minus the national insurance we got earlier, minus the pension, and minus the tax. So that's just a calculator job as well. 35,670, just make sure you don't miss anything. 2770, 32, 3352, 98, 3994, 42 is 255, 52.28. But that's per year. So to work it out per month, is it month or week we want? Weekly net pay, I divide that by 52. So I'll just keep it in my calculator, divide 52 to get 491.39, and we're done there. £1,052 per week. National insurance is calculated before deductions. Calculate Lynn's national insurance payment. Right. So up to £242, you don't pay anything. Then between these two numbers, you pay 13.2%, and then above this number, you pay 3.25%. So I need to work them all out individually. So Lynn earns 10.52. So for the upper bracket, I take away 9.67 to see how much she pays at 3.2%. That's 85 for upper. And then for your mid part, I just need to take away these two numbers from each other. 967 minus 242. Which is 725. And then on the rest, you pay nothing, so you just don't need to do anything. So now we can work out the national insurance. So for the upper part, we have got over 967 is 3.25%. So 3.25% of 85. Getting a calculator out, that is 3.25 divided by 100 times 85, 2.7625, two decimal places, £2.76. Now we do the same for the mid. So our mid one is 725 and 13.25%. So 13.25% of 725. Get our calculator for that.
13.25 divided by 100 times 725 is 96.06. 96.06. So adding these together to get the full national insurance. So adding them together, our total national insurance, £2.76 plus 96.06, 2.76 plus 96.06 is £98.82. Okay, next question. Lynn pays 4.5% of her wage into our pension and our income tax is 5208. Find the net pay. So for our pension, we need to work out 4.5% of her weekly wage, which was 1052. So using a calculator for that, 4.5 divided by 100 times 1052 is 4734. And then we need to work out her net pay. So we take her full pay, which is 1052, minus everything that we need to take off. So the 98.82. That's the national insurance. The tax is 5208. And the pension is £47.34. So we'll just get our calculator and work all of that out. 1052 minus 98.82 minus 52.08 and minus £47.34, and we get 853.76. And we're done there.
SQA National 5 Application of Maths 2025, Paper 2, Question 4. Alana earns £800 gross pay per week. National insurance is calculated in the pension's pay before deductions such as pension. Calculate Alana's national insurance payment. So Alana makes 800, which is in the middle of this bit here. So I'd start off, I don't ever get to here, I just go to 800. So I do 800 minus 242. Now I need to work out 8% of that. Now a nice tip for this is you can do times 8 divided by 100. But it's actually probably nicer to get used to turning that into a decimal, so 0.08, which is done by just doing 8 divided by 100 in a calculator. Because if you ever do higher applications of maths, you times by decimals all the time for percentages. So it's worth getting used to it now. So there we go. So then I can just do that sum all in one go on my calculator using brackets to my advantage. 800 minus 242 times 0.08 or times 8 divided by 100. And you get 4464. Just check that it's in the right time frame before I move on. National insurance payment weekly, and it was weekly, so I'm done there. Part B, Alana pays 7.5% of her gross pay into her pension. Alana's tax is 9206, calculate her net pay. Now, we've worked out the pension, national insurance in Part A, so we just need to work out the pension from £800, because it's always from 800. So it's just 800 times 7.5 divided by 100. Now remember, we could have done that with the decimal thing by changing that to a decimal first. 7.5 divided by 100 is 0.075. And I'm just putting this in here now for those of you that are moving on to higher apps. It's worth doing that and then doing 800 times 0.075, which is £60. But obviously it works exactly the same if you do 800 times 7.5 divided by 100. You get £60. So there we are. So our pension's 60, so our net pay is her full wage minus everything that she's taken off. So we're taking off the pension, we're taking off the weekly income tax, just make sure everything's in the same time frame, and we're taking off the weekly national insurance of 4464. So we just get our calculator to work out that sum. Putting it all in the calculator correctly, we get 603.3, but money is 2 decimal places, so you need to put a 0 on the end, or you will lose a mark. Saving up to buy a laptop costing £470. He earns £11.50 a week. hours each week. He's paid weekly. He pays £20.25 tax, £12.35 national insurance, and spends £42.40 on rail fares. He saves a third of his remaining money on laptops. How many weeks will it take for me to save for a laptop? Okay, so we need to work out how much he earns. So that's £11.50 times 30. So times it by 10, you get 115 times 3. 3 5s is 15, 3 1s is 3, and 1 is 4, and then 3 1s is 3. So he earns that. And then his deductions, I'll add all them up. So he £20.25, £12.35, and £42.40. Make sure they're all weekly. Yep. So that's 510. 4, 5, 6, 7, 8, 9, 10, 2, 4, 5, 4, 5, 6, 7. So he deducts £75, so he's got left 3, 4, 5 minus £75. Borrow 7, 270 left. And then it says Lee saves a third of his remaining money on a laptop. So a third is divided by 3. 3 9s are 27, so that's 90. So it's £90 per week, and it costs £470. So I need to do 470 divided by 90. So I can drop the zeros and then just count the 9s. 9 5s is 45, and then I've got a remainder of 2. So in 5 weeks, he'll have £45. So that means in 6 weeks, I'll have in five weeks I'll have £450, which means in 6 weeks he'll have 450 plus 90, which is 540. So he's not got it in 5 weeks, so he's got it in 6 weeks. It'll take him 6 weeks. You could have just counted in 90 there, 90, 180, 270, 360, 450. So I need an extra week, so it's 6 weeks.
SQA National 5 Maths 2023 Paper 1, Question 1. Josh earns £9 per hour and works 30 hours per week. His weekly outdoors are £220. This is always remaining money. He books a holiday for £566. He will take £800 spending money with him. Calculate the minimum number of weeks it will take him to save this amount. Okay, so he earns, let's just go through this, £9 per hour, 30 hours per week. So we need to work out his weekly wage. So weekly wage equals 30 times 9, well 9 3s is 27, so that's £270. But then his outgoings are £220 a week, so what he's got left per week is equal to 270 minus 220. Again, there's no need for a sum here, just count up 30, 40, 50, 60, 70, £50 is what he's got left per week. It now says Joe saves all of this, so he saved £50 per week, and he books a holiday costing $566, and he needs £800 spending money. So I need to know how much he needs. So for the holiday, he needs. Now I will do a sum just to be in 566 plus 800. Well, that's pretty easy. 800, 9, 10, 11, 12, 1300, so 1366. So calculate the minimum number of weeks it will take him to save the amount. You need to do 1366 divided by 50. So you can do that by counting in 50s if you want, or do a sum. I think the easiest way to say it is 1 week is equal to £50. That means 2 weeks is equal to £100. So I need to get up to £1,300, so I need to times that by 13. So times them by 13 weeks will give me 26 weeks. Will be £1,300. So then 27 weeks you can obviously see is 1,350, and 28 weeks he will have £1,400, and he needs 1,366, so it will take him 28 weeks. Obviously, you could have just directly divided 1366 by 50, and you would have got 27 point something, which is rounding to 28 weeks.
Emma worked overtime to earn some extra spending money. Her basic rate of pay is £12.80. She's contracted to work 37.5 hours a week and is paid time and a half for overtime she works. Last week she worked 5 days from 7:30 to 12:30, and then after lunch 1 till 5:30 on each of the 5 days. How much did she earn? Okay, so we need to work out how many hours she worked for a day. So that is 7:30, 8, 9, 10, 11, 12, that's 5:30, that's 5 hours. And then 1 till 5:30, 1300 to 17:30. So that's 1300, 14, 15, 16, 17. That's 4 hours. And then 30 minutes or 0.5, 4.5 hours. That's a really bad way to write that, 4.5 hours. So that's 9.5 hours per day. And then she did that. And then she did that for 5 days. So 9.5 times 5 means she works 47.5 hours a week. And it says she's paid time and a half for anything over 37.5. So her normal basic is 37.5. And then she's got 10 hours overtime. So how you can work out what she's going to get paid is you can think of her hours as 37.5 plus the 10 hours, and it's time and a half, so half of 10, which is 5 hours. So you can add them together. 37.5 plus 10 plus 5 is 52.5 hours as she's paid for. And how much is she paid? £12.80. So it's 50, that's a 5, 52.5 times £12.80 an hour. And that is 672 with a pound sign, exactly. And we're done there. SQA National 5 Application Maths 2025, Paper 1, Question 6. Ramani works as a salesperson for a car company. She's paid a basic monthly salary of $18.70 plus commission of 3% on her sales over $58,000. Not up to, but over. And in April, her sales were $96,000. What was her pay? So we've got $96,000. I need to take away the 58 because you don't get anything up to that point. So that's 38,000. So I need to do 3%. So let's start off with 1%. Take away 2 zeros, you get 380. So 3% times them by 3. 3 eighths is 24. 3 threes is 9, 10, 11. So our commission is 1140, so that means that her pay is 1870 and 1140 added together. So that's 11, 8, 9, 10, 1, 2, 3, 3, 0, 1, 0. And is it per month, April? Yep. So we're done there. Scatter graphs, SQA National 5 Apps, 2021, Paper 1, Question 2. Elephants continue to grow for the duration of their lives. The table shows the sample of elephants and their shoulder heights. On the grid, draw a scatter graph. So a scatter graph's just plot the points, go along the X, up the Y, be very careful. So let's just do that in bits. So the first one is 12, 1. Let's look at our scale first, actually. So it goes up in ones on the side. I can see that by counting the boxes, but up the side, it goes up in tens, 10, 20, 30, 40, 50, up to 100. So I need to be very careful when I'm plotting this. So the first one is 12 to 30. So I'll go to 12, up to 200, and then 10, 20, 30. So I'm going to plot this on now. I'm on 10, 11, 12, 10, 20, 30. There's my first dot. The next one is 17 to 50. So 17, 2 after 15, straight up. I'm at 200 and then up to 250. It's in the middle of 200 and 300. I quite double check before I mark it, and I'm fine with that. 28 to 70. So 25, 26, 27, 28. Straight on that line, up to 250, 260, 270. That'll be there. So that's 28 and 270, 35 and 275. So 35 is nice, straight along. 35, 200, 250, 260, 270, 275 would be right in the middle, so about there. And then the last one, 43 and 300. So 43 all the way up to 300. So 41, 2, 3, and I'm on the 300 line. So there we are there. And then we get a nice scatter graph. Draw a line of best fit. So we need a ruler for that. Line of best fit is when you put it, so it lines up as many points as you can, or at least that kind of equidistant, straight distance away. Best you can, that will probably do. And then just neatly drawing your line in. And there's quite a bit of leeway with a line of best fit, so don't worry if you're a little bit off. The last bit says use your line to estimate the age of an African elephant is 260. So I'm going to zoom in again to see where 260 is. There's 260 there. So if I can get a ruler or just draw a straight line, I'm just going to draw it without a ruler so you can see it because it tabs it. You use a ruler to get that line, and then you just go along to the line and straight down to where it meets the other axis. So in this case, I can just go straight down there. And I'm sitting about 21, but you might be plus or minus a few depending on how your line of best fit is drawn. But I'm going to write 21 for my line. And I'm done there. Okay, number 4, part E. Harris noticed that his journey times were affected by the time he departed. The table shows the journey times in minutes. And we've got the departure time and the journey time. On the grid below, draw a scatter graph to show the data. So a scatter graph is just simply this. You go along X and up Y and plot a point. You do the same for every single pair. And then that's it, that's a scatter graph. So let's try it. First one's 7, 32 and 22. So as going up in ones along the way, I can see that 1, 2, 3, 4, 5. And up the way, well, forget these wiggly lines. That just means that we're not starting at 0, so we're just going to kind of like skip some numbers. Then 15, 16, 17, 18, 19, 20. So we're going up in ones, so it's nice and easy. 7, 32 and 22. I'm up at 21, 2. I just put a dot or a cross. Put a wee cross because it's more normal. 736 and 21. So I go along to 736 up to 21. The next one is 810 and 37. So I go all the way along to where 810 would be. And all the way up to 37. And you'll need to watch it. You don't miss the box. I think that's there. 810 and 37. 740 and 25. So 740 and 25. 802 and 32. 802 and 32. Right there. Next one, 750 and 28. Is right there. 804 and 36. Is right there. And the last one, 745 and 24. 25, so 24. So something like that, or dots. Draw a line of best fit on your scatter graph. So a line of best fit is the best straight line you can get. It doesn't have to go through even any points, as long as each point is roughly the same distance away from the line. So I think I'll just draw mine on. Something about that's probably going to be okay. Yours will be slightly different to mine. You get quite a bit of leeway with line of best fit. So when we answer the next question, Paul plans to depart at 7:55, use your line of best fit to estimate your journey time. Your answer may be slightly different to mine, and it'll be a range that's okay. So 7:55, I get from my one that if I join it to 7:55, I'll be able to see it and join it to the axis. It's about 30 minutes, so I'm going to write that as my answer. 30 minutes. And we're done there. SQA National 5 Application Maths 2024, Paper 2, Question 8. A bathroom company counts the number of visitors in their shop in Stirling each Sunday, and the samples results as shown. Calculate the mean and standard deviation. So the mean, we add all these numbers up, which I'm not going to write out. I'm literally just going to add them in the calculator. So that's 273, and I've got 1, 2, 3, 4, 5, 6, 7 numbers, so I'm dividing that by 7, which is 39. So there's my mean. Standard deviation, start of exam paper for the formula, but the method I always use is a table like this. I call that x minus x bar, and then x minus x bar squared. And once I've got to the total at the end, that's the top of my formula. So let's take a note of our numbers: 44, 55, 32, 39, 43, 26 and 34. And then we take away the mean, that's what it means by x bar. So 44 minus 39 is 5. 55 minus 39, well that's 39, 49, 50, 51, 2, 3, 4, 5, that's 16. Use a calculator anytime you want. 32 minus 39 is minus 7. 39 and 39 0. 43 and 39 is 4. 26 and 39, that's 26, 36, 37, 39, 13, but it's a minus. 34 minus 39 is minus 5. And now you square each of the numbers in the table. 5 5s are 25. You do 16 times 16, you get 256. You do 7 times 7 is 49, ignoring the minuses. 0, 4 4s is 16, 13 13s is 169, I believe, and 5 5s are 25. And you get a total at the end. So, what's our total? 25, 256, 49, 16, 169, 25 is 540. So the standard deviation from the start of the exam paper is the square root of the sum of x minus x bar squared over n minus 1. That top number is now 540. So it's 6 now. Square root 540 over 6 is 9.486. Or about 9.5 would be probably fine. And we're done there. As to the company shop in Aberdeen each Sunday was also recorded, the mean is 49, the standard deviation is 3.2, make two valid comparisons. So let's compare the mean. Stirling was 39 and Aberdeen's 49. So on average, Aberdeen got more customers or more visitors to the shop. And that's because 49 is bigger than 39. Now the second one's about variability or consistency. I use variability. Their standard deviation is 3.2, mine's 9.5. So the number of visitors to Aberdeen shop is less varied or more consistent, and that's because 3.2 is less than 9.5. Or you could say the 9.5 place Stirling is more varied, or Stirling is less consistent. And we're done there. SQA National 5 Application Maths 2023, Paper 2, Question 5. Stuart records the chlorine levels in his hot tub. I do that every day. A sample of the levels is shown below. For these levels, calculate the mean, then standard deviation. Okay, standard stuff here. To calculate the mean, you add them up, divide by how many there are. So let's write down the sum we need to do. Always write down sums that you're doing, even if you're using a calculator. 0.8 plus 1.9 plus 1.1 plus 2.6 plus 3.1 plus 2.4 plus 2.1 in brackets, because I'm then dividing all of that by 7 because it's 7 days. So calculator, take full advantage of this calculator. 0.8 plus 1.9 plus 1.1 plus 2.6 plus 3.1 plus 2.4, and the last one plus 2.1. If I'd use brackets, I would just put it in brackets. I'll just press equals and then divide by 7. I get 2. Units are not usually required for the mean, but it doesn't even give us units anyway, so there we go. Calculate the standard deviation. From the start of the exam paper, there's 2 ways to calculate the standard deviation. I'm going to show you one of them.
So the formula I use is for the standard deviation is the square root of the sum of x minus x bar squared over n minus 1. But there is another more complicated formula, I feel, so I always use this one. Now, x bar stands for the mean. So I'm doing every number, take away the mean, squared, add them all up, divided by how many I've got. Nice little table to illustrate this. So I usually just draw a 3-bit table here. X goes here, that's all my numbers. X minus x bar, which is the top of the formula, take away the mean, and then x minus x bar squared. And at the end, you get a nice total down here somewhere. And it's this total that goes in the whole of the top of the formula. And then you divide by 1 less than the number of numbers you got and square root the answer. So let's write down our numbers, 0.8, 1.9. And then we've got 1.1, 2.6. And then we've got 3.1, 2.4. And finally, our last one was 2.1. Be very careful you don't miss any of these. I'm just going to delete this little bit that I added so I can work. Okay, x minus x bar. Now you don't really need to write down the sum you're going to do, but I'll do the first one. Our x bar was 2, so we do 0.8 minus 2. Don't worry, we get negative numbers here. You're going to get negatives. Minus 1.2. 1.9 minus 2. Minus 0.1. 1.1 minus 2. Minus 0.9. 2.6 minus 2. 0.6. 3.1 minus 2. 1.1. 2.4 minus 2. 0.4. 2.1 minus 2, 0.1. The negatives are fine because look, when you put a negative in a calculator and square it, you get a positive answer. Just put brackets around it. Let me show you. Bracket minus 1.2, close the bracket. Press squared. Oh look, it's a positive number. Now, you can just drop a negative when you square it in the calculator, just put 1.2 squared. So I'm going to do it for all of these numbers. So I've got 1.44, 0.1 squared, 0.01, 0.9 squared, 0.81, 0.6 squared, 0.36, 1.1 squared, 1.21, 0.4 squared is 0.16, and 0.1 squared I've already done is 0.01. So now I add all these up to get a grand total. 1.44 plus 0.01 plus 0.81 plus 0.36 plus 1.21 plus 0.16 plus 0.01. We get 4. Rather unlikely, but there we are. So that means we can work out our standard deviation. Our standard deviation is simply the square root of 4, because we just worked that out, divided by 1 less than the number of numbers we started with, which is 6, because we started with 7. None of this is non-calculator, so I'm not even going to bother simplifying that. Square root of, make a bracket, 4 divided by 6, close the bracket, 0.81649, 0.81649. Round that to a better degree of accuracy. It really should be 1 decimal place, but I'll put 2 just in case. Let's call that 0.82. And we're done there. His friend Colin's hot tub had a mean of 2.2 and a standard deviation of 1.4. Make 2 valid comparisons about the chlorine levels in Stuart and Colin's hot tubs. Well, let's look at our answers again. We got 2 and 0.82. So for Stuart, we had a mean of 2 and a standard deviation of 0.82. And then we can just work on this. His friend Colin had a mean, so let's compare the means first, 2.2 and 2. So comparing the mean, you always use the word on average. On average, the chlorine levels in, well, Colin's is higher. Colin's hot tub are greater than Stuart's, since 2.2 is bigger than 2. And there you go. There's a mark. Now let's compare the standard deviation. Standard deviation is about how variable the levels are. So Stuart's was 0.82, Colin's is 1.4. So Colin's chlorine levels are more varied. So Colin's chlorine levels are more varied than Stuart's. I suppose in the hot tub, not actually the people, but you'll be fine with that. I'll just do it for the sake of clarity. Now we can just write, since, again, the idea here is 1.4 is bigger than 0.82. I always just remember one statement, really, bigger.
Continuing with number 5, the company looked at the length of squash matches, and a sample of times and minutes for professional matches are shown below. For these, calculate the mean and standard deviation. It then says the length of time for an amateur match. The average anyway, the mean is 42 and the standard deviation is 7.2, so we have to make 2 comments. So I always use the formula sheet, standard deviation, the sum of x minus x bar squared all over n minus 1. There's another option on the formula sheet, but I prefer to use that one instead, because I think that one's easier to work with. So we draw a table for this. X, our numbers are 52, 68, 45, 52, 58. So being careful and note them all down, 52, 68, 45, 52, and 58. First thing I'll work out is my mean then, which is in the formula is the x bar part. So you can just add them all up and divide by how many you've got. 52 plus 68 plus 45 plus 52 plus 58 equals 275 divided by 5, 55. So then in the middle, you do x minus x bar, and then you're going to do x minus x bar all squared. So let's get my calculator for that. 52 minus 55, always use your calculator. 68 minus 55, 45 minus 55, 52 minus 55, and 58 minus 55. Now we need to square each of these numbers. Little tip, don't put minus 3 squared in the calculator unless you're really confident that you're using the correct brackets. If I do that, look, minus 3 squared, it tells you it's minus 9. It's not correct because it's done 3 squared and then put a minus in front. It should have done minus 3 like that, squared, which is 9. Tip is, just don't do it. Just get rid of a minus if you're going to square a number and just do 3 squared, which is 9. So that gives me 9. 13 squared is 169. 10 squared is 100. And then we already know 3 squared is 9 and 9. So we can add up 9 plus 169 plus 100 plus 9 plus 9 is 296. And now we're almost done. Our standard deviation then is the square root of 296 divided by, well, there's 5 numbers to start with, so I'll take away 1, 4. Square root bracket 296 divided by 4 is 8.602. Or about 8.6. You can put your units in if you want. Minutes. You're not often penalised for it at this stage, so there you are. Part C, the mean length for an amateur match is 42 and the standard deviation is 7.2. Make 2 valid comments. So part C for amateur, mean 42, standard deviation 42 and 17.2. For a pro, the mean is 55 and the standard deviation is 8.6. Big difference. Okay, so when you're doing comments, you compare both. So for the mean comment, you always start with on average. And then check what the context was, the length of squash matches. on average, the length of squash matches was bigger, smaller, greater, fewer. I'm going to use longer, shorter because it's time. So in the amateur it was 42 and in the pro it was 55. Longer in professional matches. Compared to amateur matches. And I like because in brackets 55 is bigger than 42. So the length, I think you'll get a mark for just saying on average the length of squash matches was longer than professional matches. I always like to say compared to the other thing because you want to see you're comparing them. And then for standard deviation comment, that's about consistency. So the consistency of the length of the match. So amateur 17.2. That is quite spread out. The length of matches can vary a lot. Pro, a little bit smaller, so the length of matches is more consistent. So just like that. The length of matches in professional games of squash, if you really want to over-egg this, is more consistent than in amateur games. I probably misspelled amateur there, but you won't get a mark off for misspelling. And that's because the pro game was 8.6, which is less than the amateur game is 17.2. So a smaller number means more consistency. And we're done there. SQA National 5 Applications of Maths 2024, Paper 1, Question 5. The number of files Megan downloaded each month as shown. Find the median, lower and upper quartiles and then draw a box plot. So we need these numbers in order. So starting with the units, we have got 7. And then I can see a 9. And then the tens, I've got 12. I can see 10 before that. And then 13. Easy to miss these. And then I can see 2 19s. And then moving on to my 20s, I've got 21 and 22. I can see 26. And then my 30s, I've got 34. And then finally, I've got 38, I think. And that's when you got all the numbers. So I'm relatively happy with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Have I marked that 38 off? No. Okay, so there's all the numbers. Median's the one in the middle when you put them in order. So I've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's 2 in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it's between 19 and 19. So our median is 19. And then the middle of the first half, that's between the third and fourth one, between 10 and 12 is 11. And then the middle of the second half, between 22 and 26 then. So if you don't know, you can add them up. 22 and 26 is 26, 36, 46, 47, 48. And divide that by 2 to get 24. Or you might just be able to see 24 is in the middle. Hopefully you can read it, that's 24. So we have to draw a box plot for this. So we need our smallest number. So we've got 5, 6, 7. So we'll just mark 7. You would use a ruler for this. That's 7. And our highest number is 38, 35, 36, 37, 38. We'll just mark that as 38. And then your quartiles, you've got 19 and 11 and 24. So 10, 11. So the first box starts there. And then 24 ends here. And then we need to join that up. So we'll just make that nice and big. Now, obviously, you'll be using a ruler. But yep, something like that. And then your median in the middle, which is 19, which is not necessarily in the middle, but you just draw it in the right place. There's my median at 19. I usually mark these as low. Need to join that up actually, and join that up. And then lower quartile, median, upper quartile, and high. Calculate the interquartile range for the number of films Megan downloaded. So the interquartile range is upper quartile minus lower quartile. So that's 24 minus 11. 24 becomes 14, becomes 13. Tommy also recorded the number of films he downloaded each month. Interquartile range for his is 10. State a valid comparison. So interquartile range is all about variability. Tommy downloaded was less varied than, what's her name? Megan. Or less varied than the number that Megan downloaded. And we're done there.
Was the number of words per minute he typed during a 14-minute period. We've to calculate the medians and the lower and upper quartiles. Remember, for median, you need them in order from smallest to biggest, so be careful doing that. Let's do this now. The smallest number, I think, is 37. So let me write 37, and I think that appears twice. So 37 and 37. If I miss any, I do apologise. 39 is next. And then I can see we're in the 40s now. The lowest is 42. And then we get two 44s. 42, 44, 44. And then I'm pretty sure we're getting 40. Oh, I missed 41. See, you always miss some. So let's put that in between 39 and 42. It's 41. Then there's 46, 47, 48. That was two 47s as well. Cross them off as I go so I can keep track. Then I've got 49. And then I'm going to run out of space, but it's fine. 51, 54. There we go, we can see that, can't we? Okay, so there's all my numbers. So now the median is the one in the middle when you put them in order. So I need to find the middle. A few ways to do it. You can cross off top and bottom as you go, which I will just do, but I won't cross them off. Actually, I'll just note them. Top and bottom, top and bottom, top and bottom, bottom and top, bottom and top, bottom and top. Ah, there's two in the middle. There's these two here. So the median's in the middle of these two, between 44 and 46. That should be obviously 45. But if you don't know that, add them up to 5 by 2. So now we want to find our quartiles. Just delete that little thing for clarity. So our quartiles, remember, are the middle of the first half and the middle of the second half. So I've got 1, 2, 3, 4, 5, 6, 7. So I go 1, 2, 3, 1, 2, 3. There's our quartile there. So I'll just note that. That's quartile 1. Similarly on the other side, that one must be quartile 3. Just check. 1, 2, 3, 1, 2, 3. Yep, yep. And then just to answer the question in words, so our median is equal to 45. Our quartile 3 is equal to 48, and our quartile 1 is equal to 41. Words per minute, I suppose you could write, but we'll just leave it there. Construct a box plot for this set of data. Box plot, right. So how box plots work, remember, is your quartiles go on the ends of your boxes, your median inside the box, and then your highest and lowest numbers at the end. So let's do where's our highest and lowest numbers? Our lowest is 37, our highest is 54. Lowest is 37, highest is 54. Okay, there's our picture. It does go up in ones, but double check it. So 35, 36, 37. I've got 37 right here. So that's my position. I'll just put a little dot now, and then 54, 50, 51, 2, 3, 4. Being very careful to be accurate. So there's my start and end positions on the box. And then my quartiles, 41 and 48. So 40 is here, so 41, that's where my box starts. And 48, 45, 46, 47, 48, that's where my box ends. And you really should be using a ruler, but I will just do it. I can get straight lines on this, but you should be using a ruler. 41 and 48. Connecting that box up, connecting that up to our start and end points. And then putting our median in, which we can put little lines there for clarity. Our median was, remember, 45. So I'm on 40, 41, 2, 3, 4, 5, which is right there. We can note these things. So that's our lowest, highest, median, quartile 1, quartile 3. But you should probably get away with just drawing the box and you'll be fine. Calculate the interquartile range for the number of words. The interquartile range, remember, is simply quartile 3 minus quartile 1, which we've already got twice now. So quartile 3, 48 minus 41. 48 minus 41, 7. So 7 words per min. Lynn works in the same office as Dave. Lynn also records the number of words per minute she can type. The interquartile range for the number of words that Lynn can type per minute is 5. Make a valid comment. Like, interquartile range is how spread out the data is. It's pretty much the same as standard deviation, same comment. So it's about how varied they are. Okay, so Lynn is 5, Dave was 7. The number of words Dave types per minute is more varied than Lynn's, since 7 is bigger than 5. Done.
SQA National 5 Application Maths 2025, Paper 1, Question 4. How is recorded the time in minutes it took him to drive to work over 8 days? For this, calculate the median and lower quartile and upper quartile. So I need them in order: 21, 22, 24, 25, 28, 32, 36, and 37. Now the medians are in the middle, where there's 4 and 4, so it's in the middle of here. So our median, there's 2 ways to work this out. You can add the numbers and half them, or it's halfway in between. So there's 3 numbers in between, so I need to go up or down by 1.5. 25, 26.5. Our lower quartile, well, that's going to be in the middle of here, 22 to 24. So our core quartile, or quartile 1, the lower quartile, is 23. And our upper quartile, or quartile 3, sometimes we call that, is between 32 and 36. So there's 4 numbers between there, so I need to go up by 2, 34. And that's it for part A. Construct a box plot for this data. Well, a box plot is using your upper, lower quartile and median, and then your smallest and largest number, which is 21 and 37. So let me start with 21. I'll just put a little line here, and then at 37, 35, 6, 7. I'll make that quite big actually, that line, so it's really clear. And then we go along until we hit our lower quartile, which is 23. So 23, 21, 2, 3, and draw a smaller line. And then our upper quartile is 34. So we go along to 31, 2, 3, 4. And we join that up with a box. Now you're using a ruler, of course. but I don't need a ruler because I'm on an iPad. So you get something that looks like that, and then you need your median in your box in the right place. So our median was 26.5, so 25, 26, 26.5 goes in the middle of that box. We can label that and also just connect these bits up. That should be completely straight, but there you are. So that's our lowest value. That's quartile 1. That's our median or quartile 2. That's quartile 3, and that's our highest value. Now, I do like to label it because it makes it stand out and it makes it look nice. But there you are, it's got all the information on, so we're done there. Calculate the interquartile range for the number of minutes it took Harris to drive to work. Part C, the interquartile range is just the upper quartile minus the lower quartile, Q3 minus Q1, 34 minus 23, which is 11 minutes. And we're done there. Now, usually interquartile range, actually, in apps, it's usually semi-interquartile range, so it looks like it's been changed to interquartile range here as well, but don't get worried about that. Make sure you just read the question. His colleague Lewis also recorded the number of minutes it took him to drive to work over 8 days. The interquartile range for the number of minutes that Lewis took was 9. Make one valid comment. When you compare an interquartile range, you're comparing how spread out your data is or how consistent it is. So we can just say that the number of minutes it took Lewis, is it? Lewis to drive to work were or was more consistent. And that's because 9 is less than 11. So more consistent means interquartile range is smaller. And we're done there.
A SQA National 5 Application Maths 2023 Paper 1 Question 11. A survey was conducted in favourite pie phones. The results were 80 for apple, 40 for cherry, and 60 for lemon. Construct a pie chart to illustrate this information. So to construct a pie chart, we need a protractor, but first of all, we need to calculate our angles. So to calculate your angles, it's each individual fraction of a circle. So it's 80 out of the total times 360, because it's 360 degrees in a circle. So our total, if I just put it at the bottom here, is 80, 120, 130, 40, 50, 60, 70, 80, which is handy because 180 goes into 360. So the fraction for the first one is 80 out of 180 and times the 360 for the angle. So you can do this division first, which is 2 times 180. You can do this division first, which is 2 times your 80, which is 160 degrees. Similarly for this one, 40 out of 180 times 360. Well, 360 divided by 180 is 2 times 40 is 80 degrees. And your last one, 60 out of 180 times 360. 60 divided by 180 is 2 times 60 is 120 degrees. Just double check that these three numbers add up to 360. So we've got 120, 200, 360, so chances are you're okay. So now you get your protractor and start filling this in. So I've got my protractor, so now we turn that around so that it's vertical. We make sure the middle goes on the dot, and we make sure it's lined up through the zero as best you can. Now mine won't be as accurate as yours can be because I'm using electronics. But the first angle I want to draw is 160 degrees. So there's my protractor. It's going through the outside scale. So go all the way around to 160, which is way down here. And I make a little mark at that point. I then get rid of my protractor. And we get a ruler and join this up. I don't need a ruler on my iPad. I can just make a straight line by joining it. So let me just get it back to this normal size. It's going to go to there. And then I can just adjust it and make sure it fits. And we're done there. Let's just double check that angle before we move on. 160, we're done. Well done. Let's move on to our next angle. Next angle is 80 degrees. So what we do is we get our protractor, we turn it around so that it's lined up against our new line. So putting that in the middle, lining it nice and up as best you can, pushing it up. A fine adjustment, good enough for me. And then we're looking for 80, so I'll zoom in. We're still going through the bottom scale. So zooming in, going all the way down to 80, which is over here, and moving it out of the way, and getting your straight line in your ruler, joining it up through that 0, making sure it's nice and neat to the end. And again, always double check, have you done an 80 degree? So my protractor on the middle. Yep, it's going 80, so we're good there. And now we can just measure our last angle to make sure that it actually is 120. It should be if you've done everything accurately, but a double check is always handy. Turn it around so it's going through our new line, line it up, slightly off, but I'll take that because then I'm doing that on an iPad. And you're just trying to be as accurate as you possibly can to get this. You can see it's pretty much bang on. So there we are. We can then just label our pie chart. So let me get rid of this. So the first one we drew was our apple. So I'll label the angle just to be very clear. The angle I drew was 160 degrees. That's apple. And that represents 80 people. Our next one we drew was cherry, which was 80 degrees. So there's 80 degrees. That's cherry. And that represents 40 people. And the last one we drew was lemon, which represents 60 people. And the angle we used was 120, which is in here. And I'll just put our total people at the side. You probably won't need this, but just to be very, very safe, 180. And we've constructed a pie chart.
National 5 Application of Maths 2025, Paper 2, Question 3. Alistair works in a factory that makes chocolate and he's got the results in a table. Number of people that like chocolate, different types, draw a pie chart. So if we're going to draw a pie chart, first thing we're going to need to do is get an angle. So to get an angle, you do each number divided by the total. So if we add up these totals, 34, 44, 54, 60, 80. So divided by 80, fraction of an amount, and what's it of? Well, it's of 360, because 360 degrees in a circle. So I know the answer to the first one, but just for everybody, 20 divided by 80 times 360 is 90. That's my first angle. 34 divided by 80 times 360 is 153 for my next one. And then the last one, 26 divided by 80 times 360 is about 117. So then we're going to draw that on our pie chart using a protractor and a ruler. So I've got my protractor here, so I put the cross in the middle, line it up through the 0, and I'll zoom in for you in a minute. And then we go round on our protractor until it's at 90, so I'm going through the outside scale because the 0's on the outside, go round to 90 and put a little mark. Then you're going to get rid of your protractor and drawing it up with a ruler. So I'm on my little mark, I've put my ruler down next to it, and I'm just drawing it up to the outside of the circle. And then you can get rid of your ruler because you don't need it anymore. And you can label that bit now or do it later. I'll label it as we go. So that one was white chocolate. And that was how many people? 20. So I'll put 20 in there. I'll even show the angle, but I don't really need to. I'll put it in. Put everything in it I possibly can. Okay, moving on to the next one, 153 degrees. So this time I need to turn my protractor around to go along the new line, and then I need to line up along that new line as best you can. So we go down, good enough there. So 153, we're still on the outside scale, so we're going all the way around to 150, and then adding 3, and I'll put a little mark, 1, 2, 3. Now, this mark will look quite big on here just because I am zoomed in. But there you go, you put your little mark. You then get your ruler and join it up to the centre. So there's my little mark. So I'm going to join it up and get rid of my ruler. And then technically you don't need to to draw anything for the last one, but it's worth checking. So I'm just going to put all the information in from the table again. Milk chocolate, 34. And we can see that that was 153 degrees. So I'll just put that there, 153 degrees. So the next angle should be 117 degrees. And it should be dark chocolate. And that was 26 people. So we can just check it using our protractor to see if it actually is 117 degrees. There you go, that's as good as I'm going to get. It's meant to be about 117. And you can see that I'm on the outside scale all the way around 115, 16, 17. Yeah, I'm right on 117, so I'm quite happy with that. So in terms of marks for this, it's worth 3 marks. Usually, if you look at previous papers, you get a mark for calculating your total, a mark for calculating your angles, then a mark for drawing it with labels. Labels is probably just enough to have dark, white, and milk chocolate. I like to put the numbers in as well. I like to put the angles in just to make sure they'll cover all bases. SQA National 5 Applications of Maths 2024, Paper 1, Question 10, and 2022 and 2023, all S4 pupils at Low Grove Academy achieved a numeracy qualification. The results for S4 pupils in 2022 are shown in the pie chart. So the pie chart for this one, we've got National 3, National 4, National 5. Now I can't quite see what that is, so let me just take a note of that from the paper. So that's my N3 there. This is my N4. And I'm pretty sure that's my N5, right? And the results for S4 in 2023 are shown in the table. We have to determine if there's an increase in proportion of pupils achieving in that 5 numeracy, or what fraction. So let's look at this one here. For Nat 5, we have got 144 degrees out of 360. So it's 144 out of 360 achieved the Nat 5 numeracy qualification. We don't actually need to know how many, just what fraction. And then for this one, the number of Nat 5 pupils that achieved this one was actually 50. And how many is there? Well, it's 50 plus 50, well, 8 and 2 is 10, 5, 10, 11, 12. That's 50 out of 120. So I'm basically comparing 144 out of 360 with 50 out of 120. And I can only compare fractions when it's the same denominator. Now I don't necessarily need to simplify them all. You should be able to see with 360, I can divide that by 3 to get to 120. So 3 4s is 12, 13, 14. That's 2. 3 8s is 24. I've got 48 out of 120. And I've got 50 out of 120. And the first one, 144 out of 360, is 2022. And this is 2023. Is there an increase in proportion? Yes, as 50 out of 120 is bigger than 48 out of 120. Now, yeah, so we'll leave it like that. And that's the question. Now, that's a very tough question for a pie chart question, but it is near the end of the paper, so that's how you go about that one. SQA National 5 Applications of Maths 2019, Paper 1, Question 3. The pie chart shows the number of hours overtime that 72 employees of a supermarket worked during 1 month. Calculate how many employees worked 15 plus hours overtime. So let's have a look to see where that is. If we look at here, there's our 15 plus hours there. That represents 30 degrees. So we know that 30 degrees out of the total 360 degrees of, and it's 72 employees. So we're trying to do a sum like this. We might as well simplify the fraction to make it easier. So that equals, taking the zeros off, 3 out of 36 of 72. 3 into 36, well 3 goes into 36 12 times, so that's 1/12 of 72. So counting in 12s, 12, 24, 36, 48, 60, 72 equals 6. 6 employees worked 15 plus hours overtime. The probability that an employee chosen at random worked 9 or less hours. So 9 or less hours means this segment here and this segment here. So we've got 180 degrees, that's half of them. So we need to work out how many people that is. Half of 72 is 36. Now we don't know how big this bit is, so we need to work that out. So let's add up all our angles that we've got. We've got 180, we've got 30, we've got 90. So that's leaving 9, 10, 11, 12, 20, 3, 60 degrees this bit. Now we've already worked out 30 degrees, that was 6 people. So if 30 degrees is 6 people, 60 degrees must be double that, so that's 12 people. So the total number of people, 36 plus 12, out of the total number in people in total, which is 72. So 36, 46, 48 out of 72 is our probability. But then we need to simplify all fractions. So let's half the numbers first, 24 and 36. Half them again, that's 12 and 18. Oh, I could keep halving, that is 6 and 9. And now I can't half, but 3 goes into both of them. 3 into 6 goes 2, 3 into 3 goes 9. 2/3 is the probability. You could have got there quicker if you picked a different number to divide by. This is Clelland for Clelland Maths. Hopefully you found that useful. It's a long slog getting through that. It took me quite a while to work on. Hopefully you find it useful. I really do hope you do well in your exams, and make sure you get on that last minute live stream the night before the exam. A massive boost just for the members only of the channel. Take care, stay safe, and goodbye.